Now, typically, when you want to implement a disaster recovery solution with a traditional approach, you need to provision a secondary disaster recovery data center that need to be separated from your primary data center by hundreds of kilometers and need to be attached to a power source, need to be cooled with air conditioning, it needs to be filled with bare metal that need to be managed, updated, and so on. So the complexities related to this implementation and plus the cost you need to afford and the effort you need to implement all this stuff usually can't counterbalance the benefit you obtain by having a disaster recovery in place for your workloads. This means that a typical disaster recovery scenario can be affordable only by enterprise-grade companies. On the other hand, if you had Azure and the new technologies that it can bring inside your architecture on the scale, then the scenario gets its balance again, because you can reduce the complexity, the cost, and the effort you need to spend for implementing a disaster recovery solution. And so this can be affordable now by also small and medium companies. Let's have a look about the licensing cost involved in a disaster recovery scenario for SQL Server. Here we had a huge benefit that derives from the adoption of the SQL 2019 licensing model. Till SQL 2017, you had to pay for SQL Server licensing of the DR node in a cross-premises scenarios. As you can see here, we have an on-premises node with 12 cores. We have an Azure node with 12 cores, and the total core we need to get to cover this solution is 24 cores. Now, with the new SQL Server 2019 licensing model, you have the ability to obtain one DR node on premises and one DR node on Azure included in the price of the license if your license is covered by software assurance. And so if you have 12 cores in your primary data center, you can add 12 cores for DR purposes and 12 cores again for DR purposes in Azure. And the total number of cores that you need to cover this solution is always 12. So from a cost point of view, this is a huge benefit for you. Now, when we talk about implementing Azure disaster recovery solutions for an on-premises SQL Server, and so we are talking about hybrid scenarios, our landing zone in Azure could be only a SQL Azure virtual machine. We currently don't have any technology that permits us to implement a disaster recovery solution with native technologies with using a platform as a service service as the target. And let's introduce now what are these technologies that we can use. There are basically 5 native technology we can implement for DR scenarios. Now we will go through all of these one, and we will try to highlight benefit and pros and cons of each one. Let's start with the most basic approach that is the backup to URL functionality. This is basically a way for you to make offsite backup of your database. Instead of having a backup to tape that is bring to a vault by a courier, you can directly send your backups to an Azure storage account through public connectivity via HTTPS protocol. And to do this, you simply need to issue a backup statement in Transact SQL using the backup to URL syntax. This technology is natively supported starting from SQL 2012 SP1 cumulative update 2, and is available in any edition of SQL Server. The recovery model you need to use, well, it doesn't matter with this solution. You can use full, simple, bulk logged. No, it's not important now. The complexity of this system is low to implement, since you need to simply schedule a backup job, but it can be high when it's time to recover from a disaster, because on Azure you don't have actually anything where you can recover your databases. The RPO of the solution, it's not exceptional here, and it depends upon the workload type. If you have a stressed database, it produces bigger backups, and so they need more time to be transferred to the storage account. And then it also depends on your network connectivity, because if you have poor network connectivity, you will spend more time to upload the backups to the storage account. The RTO here can be better, because when a disaster strikes, your clients lose the connectivity to the on-premises SQL Server instance, and to restore the service, you need to provision an Azure SQL virtual machine in cloud, restore all the databases on top of it, and then you need to reroute your client connection through the new instance. Well, even if you are very proactive and work with the infrastructure as code script to provision the virtual machine and how to make the restore process, you will probably need a few hours at least to exit from this disaster situation. So the RPO here is not exceptional. About the data access on your side, well, for sure you can get access and download your backups from the storage account, but you can't directly consult the data that are hosted inside them, because on Azure you don't have any infrastructure ready to restore your backups. Let's move on and let's introduce the second architecture you can implement, that is log shipping. Here we have an on-premises SQL Server instance with a database accessed by clients. We want to protect it, and to do it, we need to provision an Azure SQL virtual machines and a file share to move our backups from on-premises to the cloud. Since we are working with a Windows file share, we then need to implement an hybrid Active Directory configuration, and we need a secure channel, a secure connectivity between the on-premises data center and the Azure data center. When everything has been established, you can start preparing your log shipping configuration, and by using the native feature, 3 agent jobs appears inside your SQL Server agent, because you need to backup your database on-prem, copy the backups to the file share, and then a remote SQL agent job on the disaster recovery node will restore the backups from this file share to the Azure SQL virtual machine. This technology is supported in SQL Server since the Ancient era, and it works with any version, any edition of SQL Server. It's enough you have a SQL Server agent at your disposal. The recovery model here needs to be full, since we are working with keylog backups, and the complexity of the system is quite high, because if you wanna leverage the native log shipping functionality of SQL Server, and you want to protect more than one database, for any database you add to the whole lot, you have to you will obtain 3 additional SQL agent jobs, and this means that if you need to cover 10 databases with protection, you will obtain 30 jobs that maintain the log shipping mechanism. This can be a lot of moving gears around your architecture. The RPO here is better than before, but it again depends on your workload type, your network bandwidth, and the schedule you assign to your SQL agent jobs. What happens when a disaster strikes? Well, you first lose your on-premises data center, and to recover from this fault, you need to bring your Azure databases online, and then you can reroute the client's connectivity through the new SQL Server instance distributed in Azure. So for sure, it's a better condition than with the backup to URL approach, but because we are in a warm standby situation, and we can recover only the latest T-log backups, but we still need at least a couple of hours to come back online. About the data access on your side, this can be tedious, because on the remote side, we are now allocating a virtual machine that is dedicated to restore our backups. And this means that we have to sustain some cost, at least for compute power and storage, to maintain this virtual machine active. It would be nice to have the possibility to access our secondary database, for example, for reporting purposes, but this is feasible, but only in some situation, because you can restore your transaction log backups with the standby file, but you should do this anytime you want to restore a log backup. And this means that if you have a tight schedule to keep your RPO and RTO as low as possible, this can be tricky to maintain. Nobody stops you from mixing the configuration we've just seen and create your own log shipping custom implementation, avoiding the use of the native feature in favor of a set of scheduled tasks that execute backup to URL jobs, maybe with PowerShell. And this can permit you to simplify a lot the complexity of the system, starting with, for example, the fact that you can use a single backup job to backup all your database together. Let's go on with a more complicated but efficient solution, and let's talk about database mirroring. Well, database mirroring is a feature that has been deprecated some SQL Server edition ago, but is still there in SQL 2019. And with database mirroring, you can protect your on-premises databases with a remote SQL Server instance where you can replicate your principal database to a mirror database. As you can see here, the system can be implemented with a certificate exchange, so it doesn't require a complex network connectivity architecture, but it's common to see it, as we will see later. The replica between the principal database and the mirror database can be of two types. We can have a synchronous replica that helps you for a high availability solutions. With the synchronous replication, SQL Server ensures you that when you commit a transaction on the first node, before the control can come back to the application, SQL Server ensures you that the transaction is also replicated to the secondary node. So if a failover occurs, there's no data loss at all. This comes at the cost, because with synchronous replication, you are basically adding latency to your application layer. And so for a geographical connectivity, like in this case, we are traversing a one connection from on-premises to Azure, it's more common to use an asynchronous replication. With asynchronous replication, when the application wants to commit a transaction, it receives back the control immediately after the transaction has been committed on the first node, and then SQL Server, in an asynchronous way, send this committed transaction to the disaster recovery node. Well, I was saying that you can implement this with a certificate, but it's more common to see this kind of configuration in an Active Directory environment where we have a VPN or a site-to-site connectivity with ExpressRoute in place, and so our replica traffic goes through the VPN tunnel. Okay, to use the asynchronous replication here, you need an enterprise edition license, because asynchronous replication is an enterprise feature. So this makes your cost raising. And the recovery model here, again, needs to be full, because we're working with transaction log flows between the nodes. The complexity of the systems here is moderate because even if it's easy to establish a mirroring session between two nodes, it works at the database level, and it's very granular. You cannot group more than one database inside the mirroring session, and so for each database you need to establish a new mirroring session. When you have more database, it can be tricky to manage. The recovery point objectives here are very good because if you have a good connectivity and your workload, let me say it's normal, nothing special, well, even in asynchronous mode, your mirror database will be a little behind your principal database. And the RPO here is good, and I can say why. Because with database mirroring, you can specify in the client connection string the use of a keyword, the failover partner instance, that permits you to make your clients aware that they can point to a secondary SQL Server instance if they're not able to connect to the primary SQL Server instance. And so what happens when a disaster strikes? Well, we lose connectivity to our principal database, but we have the failover partner in place in our connectivity. And so in a few time after the database are failed over the Azure SQL virtual machine, our clients can connect to the new SQL Server instance hosted in cloud. About the data access on the DR side, here you can, with this technology, you can use database snapshot against the mirrored database to bring them online for read-only activities, for example. But you have to issue a snapshot every time you want to update the status of the remote database, because once you establish a session, then the status of the data is has been frozen there, and you won't intercept the new changes that are flowing through the log flow. Okay, it's time to talk about availability groups, which is my preferred technology in this field. Here we have a more complex scenario because the availability group is an integrated business continuity and disaster recovery solution. What does it mean? It means that you have a system composed from more than 2 nodes. And here you can see that we have a primary replica on premises that is synced in a synchronous way with the secondary replica, again on premises, for high availability purposes. Then, with the same system, we can add an additional replica in an asynchronous way hosted on Azure virtual machines. This means that you can obtain with a single technological stack a high availability and disaster recovery configuration. And this was not possible with what we've seen before, because in any presented technology before, we had to combine more than one technological stack to achieve this kind of result. And these features makes availability group the smarter nephew of database mirroring, because the replica here, both in asynchronous mode and in asynchronous mode, works in a similar way, but you have the possibility to group database together, so we can establish single availability groups for multiple databases and make them failing over consistently from one node to another. This technology was introduced with SQL 2012 Enterprise Edition, and starting from SQL 2016, is available as a basic version, also on standard edition. The recovery model again needs to be full here, and the complexity of the system is moderate because it's quite easy to be implemented, but it requires some administrative effort to be managed. Recovery point objectives here are the best of all the solutions we presented before. And the RTO, again, is very good because in this case, we don't have to deal with a failover partner, a keyword inside the connection string, but our clients connect to the primary database through a listener that you can see here. This listener is tied together with the currently active primary replica, and when a failover occurs, the listener moves with the to the new active primary replica, and the clients can reconnect to the database in a seamless way. But we will go deeper on this topic later. And additionally, this technology is fantastic since you can configure your secondary replica as readable for offloading reporting and analytical workloads, for example. And this means that the system can manage the update of the remote replicas for you, and it can make them readable. And usually in a well-configured system, your secondary replica is a little bit behind the primary replica, and you have to do nothing to maintain its update. So it's fantastic also in this side. Let's go a bit deeper into the topic, and let's explore how is made a always-on availability group under the hood. Here you can see a representation of a 3-node failover cluster, of a 3-node availability group cluster distributed on premises. You can see here that we have 3 independent SQL Server instances, each one with dedicated storage, because with this kind of configuration, we can't use shared storage, but instead each node have to maintain its own copy of the replicated database. In this scenario, the Windows Server Failover Cluster service will manage the failover cluster functions and will determine which is the currently active node that hosts the primary replica. And also it manages an availability group listener, which is composed by a virtual network name and a cluster of the IPs, and this can be moved within all the system replicas when a failover occurs. Additionally, here you can see that we have a quorum configuration involved with the cluster. What is the quorum? The quorum is a vote mechanism that ensures the stability of our clusters. You should normally have a node number of votes, and this is okay if you have a 3-node cluster, you have 3 votes, you have a node number of nodes, everything is okay. If you remove 1 node and you have only a 2-node cluster, you should add a 3rd node via a witness, that can be a witness list or a witness file share at your choice. Now, what happens when a node goes down? If we lose a node, here we lose a vote, but the remaining number of cluster nodes maintains the majority of the votes, so the cluster can stay online. But if we lose an additional node in our configuration, the remaining node online won't have enough quorum vote to keep the service up, and so our SQL Server instance goes down. This is important to be understood because when we are configuring the system in a stretched cluster like the one you can see here in this new schema, and when the when we have the third node that is hosted in Azure in a remote data center, then we need to remove its cluster quorum vote because we don't want that an interruption in connectivity between the two data centers can impact the availability of our on-premises system, which is the main system for us. And so the remaining nodes on premises will maintain a couple of votes, and we need to restore the oddity of the configuration by adding a witness to the configuration. An additional peculiarity of this configuration is about the network management part. As you can see here, we have two different networks that cannot overlap, and so we have another space for the on-premises network and another space for your Azure network, and you need to reflect those two other spaces for all the clustered resources that use an IP addresses. And so your cluster resource here and your availability group listeners here will gain an additional IP related for the remote, related to the remote network, when those resources will fail from one node to another, they may change their IP address depending on the replica where they are brought online again. And last but not least, when you implement this configuration on Azure, you have to deal with load balancer. And that's why, because when you have to deal with clustered IPs inside your cluster node on premises, the clustered IP is managed by a loopback adapter governed by the cluster itself, and where you can assign a IP of your address range. If you try to implement the same configuration or in Azure, it can be a dangerous approach, because if you define or if you assign an IP address inside a virtual machine in Azure without letting know about it to the Azure backplane, Azure can try to reassign the same IP to another resource in your network, and this may lead you to IP conflicts. To avoid this trouble, you need to deploy a load balancer in front of your cluster node. This will make Azure aware that you need to use a load balanced IP between cluster nodes. Let's see how things work when a failover occurs with one of these systems. We have here our three-node failover, our three-node availability groups system with two nodes distributed on premises and one third node inside an Azure VAT remote. And we have three replicas. One is the primary replica available for read-write workload. Then we have a secondary replica that is accessible only for read-only workloads. And we have a third replica distributed in Azure with asynchronous replication for DR purposes. We also have here a couple of workloads. One is the user's workload that needs to execute both read and writes on our databases. This workload connects through the availability group listener by specifying also the multi-subnet failover keyword in the connection string. This keyword permits you to recover your connectivity faster in case of a geographical failover between nodes. Well, our user's workload reach the availability group listener that currently has IP1 and automatically is routed to the primary replica for read-write access. The reporting system here try to access the same availability group listener, again through the IP1 and by specifying the multi-subnet failover keyword, but also adds an application intent to the connectivity that states that this workload won't only to do read-only activities on the database. This permits to SQL Server to route this kind of traffic from the listener to a secondary replica configured for read-only access. And this permits you to offload your reporting workload. What happens if we have a failover inside the on-premises network? Well, as you can see here, the replicas lost their identity for a while, and then a new primary replica will be elected, and the replica flows through the secondary replicas will be immediately restored. Now, when our customers and our reports workload want to gain access to the database again, they still point to the availability group listener, and again, they are routed to the primary replica or to the secondary replica, depending on the application intent or specified inside the connection string. This transaction between the previous primary replica and the currently active primary replica is seamless for the customer, since they still need to try to reestablish the connection until the availability group listener goes online again, and then without any change to the connection string, they can gain access to our database. What happens if a disaster strikes and we completely lose our on-premises network? Well, in this case, the remaining third node distributed in Azure, as I was saying before, it has no enough quorum vote to start automatically. So you need to connect to your third node, and you can automate this process, and you need to force the start of the failover cluster service, and then you need to failover forcibly your SQL Server availability group on the disaster recovery node. And this brings your database online again with an updated availability group listener that now listen on the secondary IP assigned to it. And now, when the users and when the reports application are able to resolve the new IP, so we need just to wait for the DNS record TTL before we can reestablish a connection. Then, when this happens, our on-premises solution can reconnect through the new primary replica and reach our database again in a seamless way. Let's say that you can increase the complexity of the system whatever you want by adding, for example, distributed availability groups configuration that were released with SQL Server 2016. But this is well, something that is not so important for us now because it's quite complex configuration. Here, you can see that we have a completely standalone availability group system on premises and a completely isolated availability group distributed in cloud, and both those availability group systems are linked together by the distributed availability group. Okay, I was saying before that with starting with SQL Server 2016, you could also implement a basic form of availability group with standard edition. Well, this basic availability group feature has a couple of limitations that makes it more similar to a database mirroring approach than a true availability group system, because With this technology, you can only maintain one database in replica for each availability group. And this means that for each database you want to protect, you need to implement an additional availability group, and this can bring you additional complexities when you're working on Azure and you need to include a load balancer virtual IP for each availability group listener you need to provision. Additionally, with this technology, with this feature, you can only have one secondary replica that can be synchronous or asynchronous. You cannot have more than one availability group replica, and this means that you can use this technology only for high availability or disaster recovery, while the full feature permits you to have more than one secondary replica, and so you can mix the things together. An interesting thing here is that you can combine the different technologies together. In this example, you see here that you can mix an existing failover cluster instances distributed on premises, and you can protect it with always-on availability group for disaster recovery purposes in cloud. So that is, if you have an existing on-premises failover cluster with its remote storage, so the database are hosted on storage area network somewhere, and you have your SQL Server services that is able to jump between the two on-premises failover cluster nodes, you can add on top of this configuration all the whole stuff you need to implement a availability group with a DR node distributed in Azure. In this way, this database hosted in the remote shared storage will be replicated to a secondary independent SQL Server instance here with its own storage in cloud. And then you'll obtain an availability group listener that normally is point to the currently active SQL Server failover cluster instance node, but in case of a disaster, it can be brought online on the secondary node in a transparent way for the client connectivity. If you are curious about this kind of implementation, just know that this can be implemented with a few steps, and it can also be implemented on top of an existing system with minimal downtime during the implementation. So it's easy to extend your failover cluster instance with this technology. If you're curious about it, just have a look to this YouTube video I'll publish later today, where you can find the whole process described with all the PowerShell script you need to implement to obtain this kind of configuration. And in this video, I've implemented the extension of the failover cluster instance on premises with the basic availability groups in order to be able to use SQL Server standard licenses in my example, but with a few changes to the PowerShell script that are shared with you in one of my GitHub repos. You can implement this stuff with the full availability group feature related to the Enterprise Edition SQL Server. Okay, last but not least, let's introduce the last technology, that is Azure Site Recovery. What's Azure Site Recovery? Well, it's an Azure service that is not natively related to SQL Server. Its own job is different. It doesn't matter if you want to protect a normal application server or a SQL Server for him. He normally works as an orchestrator for disaster recovery's implementation between two different data centers, where one of the two data centers or both the two data centers can be Azure locations. So As an orchestrator, it can help us by governing the failover process between the two different sites. And additionally, it can also help us by replicating a virtual machine from one site to another. Here you can see an example scenarios where we have a web server that is directly protected by Azure Site Recovery. This means that this web server is under Azure Site Recovery replication to Azure. On Azure, we don't have a live virtual machine array that is currently replicated by Azure Site Recovery, but instead the web server is replicated to a storage location, and then a virtual machine will be spawned when the disaster occurs. This helps to keep the cost of the solution as lower as possible. Then, in this picture, we are using also Azure Site Recovery to orchestrate the failover of a complex always-on availability group implementation, where we have a three-node cluster that uses a synchronous replica on premises and an asynchronous replica in cloud. When the disaster occurs, we completely lose our on-premises data center, and then Azure Site Recovery can detect it and start the recovery plan for our disaster recovery solution. And this leads you to obtaining a virtual machine that will be started starting from the replicated disks of the web server, and then the Azure Site recovery plan can issues all the commands you need to forcibly fail over your SQL Server workload to the Azure SQL VM. And in this kind of activities, we are helped by the highly integrated PowerShell commandlets that are available for SQL Server. You can insert inside the recovery plan both the native SQL Server module commands, as well as to manage an availability group scenarios like this one, or you can also add the database tool, DBA tools, PowerShell modules, commandlet that are very powerful. When the service is online again on the remote data center, your client application can reestablish the connectivity to the DR node that has been fed over for SQL Server. This technology works also in more simple scenarios. Here you can see the previously showed web servers that is now linked with a single node SQL Server virtual machine. In that case, you can use the ASR replication also to cover your single node SQL Server virtual machine, and in case of a disaster, the Azure Site Recovery will simply spawn a couple of virtual machines on the Azure landing zone for both the workloads. And if you have to work with more complex scenarios on premises, like using a SQL Server failover cluster instance, but this is a scenario that it can be supported again with Azure Site Recovery, but the things here get more complicated because Azure Site Recovery cannot support natively a failover cluster with shared storage on premises. So you need to implement a replica through, for example, database mirroring to a third node on premises, and then you can protect that third node with the ASR replication. And then when you fail over, the third node will be turned on the Azure side. Well, I think that's all about the whole picture of all the different BCDR technologies you can implement in Azure. I'll leave you some links for you to extend this topic. You can find my demo scripts with the failover cluster instance, basic availability groups set together with SQL Server Standard Edition. Here's the link to my GitHub repo and the YouTube video. Well, I update the link in the presentation later today to a new video recorded in English for you. And there's the official documentation where you can find all these techniques explained, and a couple of other links. I would like to notify you the DBA tools, PowerShell modules that can really help you while implementing these kind of configurations. So that's all on my side. I would say a huge thank you for your attention. If you have any question, I'm here available for you. Otherwise, thank you and see you at the next event.
There aren't any questions. Thank you.
Okay, I think that's all. Thank you so much for your help.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances, to yoga classes, to pizza making and fitness challenges, to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play staff poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com.
Hi.
Hi, hello again. Our next presenter is Dejan Slavovic.
Hi to all.
Dejan, the screen is yours.
Thank you. Okay, can you see my management studio?
Yes,
Okay, great.
all of us.
Great, and now you can see my presentation. Hi to all. My name is Dejan Slavovic, and I will be talking about SQL Server Intelligent Query Processing, a marketing name that Microsoft came up with that has cool features in it. It spans SQL Server 2017 and 2019. In 2017, these features were called Adaptive Query Processing, and now in SQL Server 2019, it's called Intelligent Query Processing. Big thanks to sponsors, global partners, global supporters, gold, silver sponsors, past, for making this possible. Thanks to all attendees for being here. Thanks to the organizers. And let's start. A little bit about me. I'm a senior database developer living and working in Zagreb, Croatia. I work in a company called Span. My passion is performance tuning and optimizing SQL Server databases and troubleshooting. I'm also a Microsoft certified trainer. I hold numerous Microsoft official curriculum seminars here in Zagreb, online and offline. I'm a co-organizer for 2 events, one happening every month. This is a past meetup SQL Server User Group Croatia, and the yearly event SQLSaturday Croatia that will be in September of next year. Let's go to the agenda. So today we will talk about features that are in adaptive query processing in SQL Server 2017, and all the features are in under the marketing name Intelligent Query Processing. First of them is adaptive joins, a feature that enables SQL Server to choose between nested loop and hash match join and to make the query go faster. Second one is interleaved execution that is applied to multi-state and table-valued functions. The third one is memory grant feedback, allowing SQL Server to more precisely grant memory to execution plans and queries that are executing on SQL Server. Table variable deferred compilation, similar to interleaved execution, gives SQL Server a chance to take the exact count of rows from the table variable and put it as a cardinality in the developing an execution plan. Then we have batch mode on row store. SQL Scholar UDF inlining, very cool feature that allows SQL Server to unwrap a user-defined function and use it in the execution plan as a set-based operation. And at the end, we have approximate query processing. We have a new function, approx distinct count, that gives approximate values to us, but it's faster and uses less memory. Here is the illustration of intelligent query processing feature map. The blue boxes are features that are already available on SQL 2017 under the name of adaptive query processing. Those are batch mode adaptive joins, interleaved execution, and memory grant feedback in batch mode. Green boxes are available on SQL Server 2019. So first one is raw mode, memory grant feedback. So memory grant feedback is now possible on raw mode queries, execution plans, also not only on batch mode. So you don't have to have a column store index for this to be available to SQL Server. We have table variable deferred compilation, batch mode, and row store. This color UDF inlining and approximate query processing, approximate count distinct function. I didn't say this, but if you have any questions, I would kindly ask the organizer to mute himself because if you have any questions, please feel free to put them in the chat, or I don't know if you can unmute yourself, but if you can, unmute and interrupt me whenever you want and ask a question. First of the features is adaptive joins. What is adaptive join? Adaptive join is a new query operator in the execution plan, as you can see on this slide. So we have a new operator that decides in runtime. So query execution plan is built, created, stored in the cache, and if it has adaptive join operator in it, this means that when query is executed in the runtime, it will choose between nested loop and hash match and execute, join the row sets with nested loop or hash match. This is available on SQL Server 2017 and 2019, but it is available in batch mode only, meaning that in the input table that goes into adaptive join, you need to have column store index on it for this to be available. So first step is to access the table based on column store index. Based on column store index. The second step is to go into adaptive join, and based on the adaptive join threshold, decide whether to use hash match or nested loops. Steps 3 or 4 are self-excludable, meaning that if the step 3 executes, step 4 will not execute, and if the step 4 executes, the step 3 will not execute. This feature handles oscillations in the input row set, meaning that if low number of rows go into the input of adaptive join, nested loops will be used, and if high number of rows go into the adaptive join, then the hash match will be used. And this feature is only available for select queries, and obviously there is some overhead because SQL Server has to decide in runtime whether to use nested loop or hash match. Let's see how this looks in practice. We will use for most of the demos wide world importers data warehouse. So we will use that warehouse, and we will create a clustered column store index on fact order, because fact order table will be used in subsequent queries. So let's create a column store index. This will take a couple of tens of seconds. It's finished. And now we have a simple join in the query, join between fact order and dimension stock item on stock item key. And we are filtering in fact order quantities that are 360. in the first query. In the second query, 361. And in the last query, we completely disable batch mode adaptive joins with this hint. And we use 361 as a filter parameter. Let's include actual execution plan and execute all three of them in one go. Let's take a look at the execution plan. And in the first two execution plans, you can see adaptive join here and here. You can see a column store index scan operator here. So we said that if you want to use adaptive joins, SQL Server has to access the input table into the join operator by a column store index. It has to be in batch mode. And coming into adaptive join, we see that there is a new property here called adaptive threshold rows that determines whether the nested loop or hash match will be used. This value is 67.89, as you can see here. And estimated join type of the adaptive join is hash match, and actual join type is hash match. So to recap, SQL Server had built the execution plan with adaptive join, and when executing the query based on this execution plan, it decided to use hash match join operator to join the two row sets. In the second query, we also have adaptive join. But this time, adaptive threshold rows is a bit lower because this is a different execution plan. Because query is not safe, so it's not parameterized. And the threshold is around 6. Estimated join type is now nested loops, and actual join type is also nested loops. So this time, SQL Server used the adaptive join to join the two row sets with nested loop operator. In the third query, we disabled the adaptive join on batch mode, and we get a nested loop join operator to join the two row sets. Okay, are there any questions about this? No? Okay. Let's go to the second feature. Second feature is memory grant feedback. It's available on batch mode execution plans in SQL 2017, and in 2019 it is also available on row execution plans, row mode execution plans, and batch mode execution plans. This feature enables SQL Server to adjust memory given to a query or to an execution plan. You all know that when SQL Server builds an execution plan, it, amongst other things, grants certain amount of memory to that execution plan, and it can be wrong about that memory grant. If it is wrong, the second time the subsequent executions of the same query using the same execution plan will benefit from memory grant feedback, meaning if the SQL Server has given too much memory, the memory will be lowered, and if it has given too little memory, the memory will be increased. So if the granted memory is too big, and at least 50% of granted memory was used by the query, there will be no adjustment. But if the memory was too low, and in execution plan we see a spill to 10 dB, there will be, of course, adjustment of a memory grant to that query. You can imagine that it can happen that there is a memory increase, memory decrease fluctuation. We could be in a loop, but this can happen in SQL Server because there is a disabled feedback mechanism for these kinds of statements and these kinds of conditions when this happens. Let's see how this works. We have a script on worldwide importers database. This time we will include the actual execution plan, and I have an extended event session here. I will show you the events being captured in it. So the events I'm capturing are memory grant feedback loop disabled and memory grant updated by feedback. This second event, memory grant updated by feedback, will be captured when I execute this query I have in a script. I will now start the session and watch live data because I'm not storing this to disk. I will include the actual execution plan. Okay. And execute the query. Okay. In the execution plan, we see a warning sign on the select statement saying that the query memory grant detected excessive grant. So SQL Server has given too much memory to this query. It has given him 23 megabytes and used was only 120 kilobytes. You can see that here. So memory grant was 23 megabytes and used was 120 kilobytes. If we execute this query again, we now don't have a warning on the select statement. And if we go to the properties window, to the memory grant info, we can see that property is memory grant feedback adjusted is saying yes, adjusting. If we executed this query a few more times, this property would say yes, stable. So when this query memory grant stabilizes, it would say here yes, stable. Let's take a look at the live data of the extended event. We captured memory grant updated by feedback, and we have the same memory amount here, 23 megabytes. Sorry, what happened? This is the amount of memory that SQL Server has given, and this is what he now thinks that it should be given, 1 megabyte. Okay. So this is a very cool feature that enables SQL Server to avoid spills to 10 dB, which is very slow, we know, and to increase concurrency on the system by decreasing the granted memory when the granted memory was too big to the query or execution plan. Next feature is interleaved executions, available on 2017 and 2019 both. It applies to multi-statement table valued functions. As we know, for multi-statement table valued functions, SQL Server Query Optimizer from version 2014, so 2014 and 2016, had a fixed cardinality estimate of 100, and before that it was 1. And from 2017 and in 2019, SQL Server, when he builds a query execution plan, when he comes up to a multi-statement table valued function, it pauses the optimization, executes the table value function, captures the accurate cardinality, and then resumes optimization. This enables SQL Server Query Optimizer to build the execution plan with exact cardinality of the multi-statement table value function. And this applies to select-only queries. Let's see this in action. We will use wide world importers DW, free procs cache. Don't do this on production, free procs cache. I will create a multi-statement table value function that has two input parameters, start and end date. The multi-statement table value function returns a table named foo, which has one field, order key. So I'm fetching from fact order, where order date key is greater than or equal to start and less than to end, and storing order key into foo table. And then I'm returning the result. Let's include the actual execution plan. Excuse me. First query and second query are exactly the same. The only difference is that at the moment I'm in the compatibility level of 150 because I executed this. So I'm in the compatibility level of SQL Server 2019. And after I execute this query, I will lower the compatibility level to 130 or to a SQL Server 2016 and execute the second query, which is the same as the first one. Let's see what happens. Okay, we got the results. In the execution plan, we have an operator accessing the multi-statement table value function. And this operator has estimated number of rows to be read as 5281. And actual is exactly the same, 5281. This is because the SQL paused the optimization when building this execution plan, executed the multi-statement table value function, captured the accurate cardinality, and then resumed optimization. In the second query, where we are on SQL 2016, we see that estimated number of rows is 100. And the actual number of rows is 5281. So SQL Server made a mistake in the cardinality estimate, and this could all go wrong if this difference was very, very high. Any questions? Okay, let's go to the next feature, table variable deferred compilation, which is pretty much similar to the previous one, but it is available only on SQL 2019. This feature enables SQL Server Query Optimizer to get the actual row count of the table variable. Before that, it was a one-row guess. It was fixed to one-row cardinality estimate. This feature doesn't add column statistics to table variable because this is not possible, and it doesn't increase your compilation frequency. So SQL does not recompile the query. It stores the execution plan to the plan cache, but with the actual row count. As you can presume, what happens with the variations in table variable cardinality? What if I execute the same query with different number of rows the second time after the query plan has been cached? Well, then you have a standard parameter sniffing problem, which is not always a problem, of course. And you can deal with it with option recompile or option optimize for unknown, optimize for, and stuff like that. Let's see how this works. So again, we are on wide world importance DW. I will include actual execution plan. And I have a table variable foo, which has one key, order key, and I'm filling it in with order key field from fact order and filtering with the same dates I used in the previous example to get the same cardinality. And I will execute this. In the last query, I'm joining fact order with table foo to see the estimate on the table foo. Table variable foo. Sorry. So in the execution plan, I have an operator accessing table variable. And as you can see here, estimated number of rows to be read is 5281. And actual number of rows is exactly the same, 5281. So SQL Server with this feature is absolutely accurate using table variables and makes the optimal execution plan because of that. Next feature is Scalar UDF inlining. It works only on SQL 2019. It enables SQL Server to inline or to expand the user-defined function, transform it into relational expressions that are set-oriented, and on SQL 2019, it is possible for query execution plan to go into a parallel, which was not possible on previous versions of SQL servers. On previous versions of SQL servers, you had iterative invocation. You didn't have costing in the execution plan, which we'll see in demo. And the execution was interpreted and always serial. Whenever you had a Scalar user-defined function in your query, the execution of query plan was always serial. There are some requirements that you have to satisfy in order to SQL Server to use UDF inlining. There are a lot of them. I will not go through all of them, but one of them is, for example, user-defined function. If it is natively compiled, then inlining is not supported. If you use the user-defined function in group by or order by, then inlining is not supported. User-defined function cannot use a table-valued parameters or table variables inside its body if you want inlining to be used by SQL Server. I will upload the slides and demo scripts to the SQLSaturday Plovdiv 2020 site, so you will be able to download them and look at this by yourself. The next feature is approximate query processing, available on SQL 2019. Use cases for this is when you have very large data sets that you want to count and you are willing to sacrifice precision over responsiveness. So this function is should be used on very large data sets when you don't want to wait a lot of time and you don't want to use a lot of memory to count rows, but you are willing to sacrifice precision. It guarantees up to a 2% error rate within 97% probability. There is a link you can take a look at, and there is some heavy math I will not go through because I don't understand it behind this. To support this function. This function uses less memory than count distinct, standard count distinct function, and it is faster on large datasets. So let's take a look how this works. It's very simple. You just use it as a count function, but the name is different, approx count distinct. You give it a field, and in the other query we use count distinct and ordinary count function call. Let's include the actual execution plan and execute this. And as you can see, I included set statistics time on. First query took 9 milliseconds of CPU time, and elapsed time was, no, this is parse time, sorry, 31 milliseconds of CPU time and 29 milliseconds of duration. And second one, 78, so it was slower. And what is more important, if we take a look at memory granted, the first query using approx count distinct used only 3 megabytes of memory. And the second query using standard count function used 23 megabytes of memory, so 7 times more. So using approx count distinct function, you increase concurrency on your SQL server. The last feature I want to talk about is batch mode on row store. It's available on SQL 2019. So this is a feature that enables SQL Server not to use row mode in execution plans, but batch mode. Batch mode means that it will not execute the query row by row, but in batches, and it will be faster because of that. You don't have to have column store indexes for this to work. You can use row store indexes and have benefits of batch mode execution plans. Scenarios where you would use this are analytical queries on OLTP DBs, joins, and aggregates. When your queries are CPU bound, and if column store index is too much overhead for your OLTP database, then you would benefit most from the batch mode on row store. SQL Server uses heuristics to choose the batch mode plan. Operators supported in the query execution plan are hash, join, hash aggregates, sorts, window aggregates, filters, concatenations, and compute scalar. There are also some limitations like only disk-based tables and indexes. You cannot use in-memory tables, and you cannot use lobs, sparse, column sets, and XML. How this works? Well, let's see. We will drop that index that we created in the first demo. So I will drop column store index on fact order. And now I have two exactly the same queries. The only difference is that in the first query I'm allowing batch mode, and in the second query I'm disallowing batch mode. So let's run them, include the actual execution plan and run them. Okay. So in the execution plan on any of the operators, you can see that actual execution mode is batch on the first query. And on the second query, it is row. So second query is executing the query row by row, and the first query is executing it in batches. So you don't have to do anything special to use this feature. You just execute the query on SQL Server 2019, set batch mode on row store to on, and SQL Server will, based on heuristics of the query execution plan, will decide whether he will use batch mode or row mode plan. I did all the demos. Do we have any questions, maybe?
Hi, we haven't got any questions now. And thank you very much.
Thank you. Just to recap, we talked about intelligent query processing and adaptive query processing. We talked about some cool features that SQL Server gives the possibility to execute queries faster, to build more reliable and scalable execution plans. And I would just like to stress that you have to, if you migrate your database to SQL 2019, you have to do some thorough testing to see if these features are helping. They will most probably help, but sometimes they can produce execution plans that are even slower than they used to be on the lower versions of SQL Server. So test, test, test. That's all for me. Thanks to sponsors, thanks for attending, thanks to the organizers, and see you next year, hopefully.
Yeah, see you next. And thank you to this perfect style of presenting.
Thank you. Bye.
Bye.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialize with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play staff poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances, to yoga classes, to pizza making and fitness challenges, to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at pokerstarscareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances, to yoga classes, to pizza making and fitness challenges, to musicians, sunrises, and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play staff poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances, to yoga classes, to pizza making and fitness challenges, to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play staff poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play staff poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative, from TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own product with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com. At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative, from TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com.
So, the next topic is row-level security deep dive, and presenter is Andrei Melanchia.
Okay, hello, hi. Hope everything is good with everyone. Let me just share my screen. Okay, so can you see my screen and hear my audio?
We see and we listen you.
Okay. Hello, everyone. Glad to be here or there again. So how are things? Is everything okay? So how's the conference so far? Enjoying the conference? Anyway, we'll start in about 1 minute at the right hour. Let me know if you have any questions. I'll just have the chat here for any questions you have. Okay. Okay, so I think we can get started if that's okay. Welcome everyone. This is going to be yet another session, but this time on row-level security. So let's have a look before we start. Okay, so today we're going to focus on row-level security, but before I've actually presented a few sessions, especially in Bulgaria. So technically, this will be at least my 25th session for Bulgaria. I've done at least 24 sessions before this, and I'm really happy to present once again both this session and coming up in 2 hours. I'm also going to present Machine Learning is Full of Stars, an Azure story, so you can have a look at machine learning, how to get started with machine learning, using Azure or not, but getting started with machine learning. And let's have a look at the session today. And the session today is row. Okay, so what are rows? So the first question is, what are rows? We already know that there are rows on each other's computers. You have rows in tables, etc. These are perfectly normal, but is it really the name? So the first name that you see is actually the name for rows, which are the way you do it on a boat. So you row on a boat. This is the first option. So let's clarify this for now. You also have the death row, which is very dangerous. So you can get killed there. That's of course not something that's nice. And we probably have something like a line of things, people, animals, etc., arranged next to each other. So this is a row of people. So you have a row of people watching things. And finally, of course, the row that we want is slightly different. Now, we have a row of rowers at this moment. Everyone is trying to row their respective canoes or kayaks, if you prefer. And this is going to be row-level security deep dive. And of course, my name is Andrei Melanchia. I'll be presenting this for the second time. The first time I've actually presented this was also in Plovdiv, but specifically for Power BI. Today, I'm going to present this very detailed for SQL Server, but towards the end, I'll actually mention one or two things about Power BI as well, but mostly about SQL Server. And the image here is actually an image that took place a few years ago, and I'm not sure if you can find me, but I am here somewhere in this image. So let me just remove the black and white from here and try to get you to guess where I am. I know that this remotely is not very easy, so I am actually here. So I'm one of the fattest guys around here, but I still do a lot of kayaking on this day. And usually when I go to this place, it's around 50 kilometers. So I do a lot of rowing and things like that. And just to mention that this is the dam here in Portugal that has 1 cubic kilometer of water. So think about this. It's 1 kilometer by 1 kilometer by 1 kilometer of water. Okay, this is like a Borg cube, something like that. And of course, this is much wider. It's not really a cube, but deep dive, it's about 120 meters to the bottom of the dam. Hopefully, I'll never be there, but in any case, I usually play around with the water, but on top of the water. So hopefully, this is okay by rowing and things like that. Anyway, before we start, let me just mention one final thing, which is just this morning, I was presenting a session for IT Pro Dev Connections in Greece. And that session, I had to add something which is very common these days. So I decided to copy the slides. And you know that recently, we've had a lot of monoliths come along, right? And this proves that we are not alone. We have a lot of monoliths. And in this case, there's monoliths in Australia, in Romania, in the United States. In the United States, it's a very capitalist monolith because McDonald's already used it for something. And of course, finally, you have places like Portugal, etc., that actually use monoliths for an entirely different thing. So you have monoliths to take a bath. And at the end of doing some rowing, it's a good idea to actually use it. So, of course, we have so many monoliths coming up, and this is going to be something very fun. So as if it wasn't enough for everything that happened in the year 2020, now we have monoliths, but then they can come to life, and that's even worse. Anyway, let's have a look at some of the content here, and let's have a look at the deep dive contents. Let's do this. Let's have a look at the deep dive content. I don't have that many slides. These are basically the slides that I wanted to show you, and the rest is mostly code. So let's have a look at this. And first of all, let's define the environment that I'm in. This is going to be Management Studio. You can try these scripts with Azure Data Studio or any other thing that just runs code. You can try this directly. If you are using a SQL database in Azure, you can try this directly there. But basically, this is okay for using a SQL database. Now, I have two. I have a SQL server, a SQL database somewhere in Azure, and I also have a normal server, a SQL Server 2017 in this case, that I'll do some other demos as well. But first of all, we'll start with the SQL database. It's exactly the same. The SQL database behaves the same as a SQL 2019. The reason I'm using this is because I can, and it's easy, and I had the test database already there for me to play around. And then I'll try 2017 because there are one or two different things to do. Actually, I was kind of wrong. There was one extra slide that I need to show you about all of the things where you can do row-level security. Let me show you this now, just out of curiosity, as we're mentioning in this. So where can you get row-level security? And in this case, you can get it from you can get it from SQL Server 2016 on. So that means you can receive row-level security content with 2016 SP1 with any edition, and this is amazing. Okay, so if it is any edition, that means that even Express Edition allows you to do this kind of thing. 17 has everything, doesn't need the SP1 or anything like that. Just 17 and 19 are fully working, but there are some bugs, and I'll show you the bugs at the end of the session. So first of all, I'll show you everything you need to know to use row-level security, and at the very end, I'll try to hack it for you. In the last 10 minutes, something like that, I'll try to hack it for you so that you know that there are some security concerns, and in that case, you can protect yourself against them. The best option is to just use the most recent version, which is 2019, and that fixes the problem. But if you are using older versions, you need to fix some things. So this is also working in Azure SQL database. You also have something which is called Azure SQL Managed Instance, and this is basically a virtual machine with SQL Server inside, but Microsoft manages this for you, so you don't have to do any kind of administration. You just have databases inside. You can create them, and it's almost 99% compatible with normal SQL Server, but still it's managed by Microsoft, so you don't have to worry about storage or worry about optimizations, etc. It's not your problem. You can do it, but it's not your problem. Anyway, you also have something which is new. Well, not new. It was previewed a year ago, in November last year, but it only came out to general availability, so to normal usage last week, which is Azure Synapse Analytics. And you have something that used to be called SQL Data Warehouse, which is basically a data warehouse database, a massively parallel processing database with 60 nodes in Azure. So you can use that one as well, and row-level security is also available there. No differences. Actually, all of these have very little differences to work with. All of these are from the Microsoft SQL world. So all of these will work pretty much the same way, although I will have to add one or two things about the Synapse Analytics, etc. at the end of the thing. It actually adds a few functionalities, but we'll see that a bit later on. And of course, you have it's now called a dedicated pool. The data warehouse part with all of the 60 nodes, etc., is now called something called a SQL dedicated pool. And in that case, it was previously called SQL Data Warehouse, so you probably see some documentation about that with the old name. In any case, it's fully supported. You also have something called a serverless pool, which doesn't really have any tables. It only has external tables. So with Synapse Analytics, you can have both normal tables in dedicated pools, but in both of these, you can also have some external tables as well. So if we have some time towards the end, we might try to have a look at Synapse in the next session. So I'm doing a session on machine learning in 1.5 hours, so feel free to have a look. And I will also talk a bit about Synapse and how you can do machine learning there, but just also give you an intro about Synapse itself. Anyway, you can also use Power BI, and to do this, you need to use a DAX expression. It's not very difficult, so most of the DAX expressions for row-level security are quite simple. You don't really need to know advanced DAX. It's just something is equal to something, so very simple. You also have the possibility of using SQL Server analysis services, and in that case, you can use either DAX or MDX languages, depending on if you are doing a tabular or a multidimensional model in that case. You also have Azure Analysis Services, which also support row-level security using DAX. Azure Analysis Services are exactly the same as SQL Server Analysis Services, but they are just a managed service in the cloud, but they only support the tabular model, so that means that only DAX is available in that case. But there is, of course, more. This is the Microsoft world. There is, of course, more, and you have Oracle, which also supports row-level security. You have Postgres, starting in version 9.5. I have no idea what the Oracle version is. I honestly haven't used Oracle or Postgres much in the last few years. Fortunately, let's say it like that. But they do have row-level security available if you decide to use them, and the functionality is pretty much the same. There's much other places that also have row-level security. This is normal. This is expected. But in our case, we'll focus on the SQL world, which is the first 5 here, and the functionality and the syntax, etc., is always going to be the same. If you are using DAX with Power BI, it's slightly different. In a few days, I promise until the end of the year anyway, or I will try to promise until the end of the year, that I will have a new website running with all of the with all of the code and all of the things for all of my sessions. And I have code from the previous session using Power BI when I did the first time row-level security, actually in Plovdiv, but just specifically focus on Power BI. I also will make that script available for you as well. It's a list of instructions that you have to do, and you can try Power BI row-level security there as well if you'd like. Okay, but we'll focus on the first 5 just in case, but the concept is always going to be the same. Okay, so anyway, you have an etc there as well. Okay, so anyway, let's have a look at the actual script. As I mentioned, this will be fully scripted, and you have, of course, row-level security. This is the second version because the first version was only for Power BI. This is the second version. And all you have to do is to create a database and then just run the scripts on this database. Ideally, an empty database. Don't use this on the master. Don't use this on a production database. That's just terrible. But in any case, it's very easy to use. I still have a lot of sound. Anyway, but in any case, as I was mentioning, let's have a look at this. And in my case, I'm actually using this server somewhere in the clouds. Okay, I'm using a SQL database in the clouds. To be honest, this one is also a SQL virtual machine where I'm running this, also in Azure. So this is a SQL database, a SQL server here, but this is technically also in Azure, but still it's a normal SQL server, pretty normal one. But let's have a look at this database here at this moment. I have a whole bunch of tables. That's okay. I will drop all of the relevant tables at this moment. Okay, so make sure that I don't have any content here that could be used to screw up things. So let's just refresh. Okay, so currently I don't have anything that I would need to use, and I'm going to use some tables, interesting tables called sales managers and view for sales as well. So let's get started. So first of all, we need to create some users. This is row-level security. So you have different users. And these users will be used for different things. So let's say that this is a store, okay, and that store will sell underwater equipment and things like that, whatever that is. And then you have a manager for the stores in Portugal, a manager for the stores in Bulgaria, a manager for the stores in Ukraine, and then you have a global manager which should have allowed access to all of the things around the world. And then you have someone who's not a manager, okay? So we have 5 different users. We'll try to use the top one, the bottom one, and a few of these in the middle to try a few things. Now, first of all, it is a best practice, and I'll detail this towards the end. It is a best practice that you add a schema. So you need to add a schema, and I'll just call it UW, so that means underwater. Okay, it could be a different one. You can call it whatever you want. And I'm going to create a sales table. Now, the sales table doesn't really have much. It just has some records. Let me just show you this. It has some records. And the records are just going to be an order ID. I don't even care about the products or anything like that. This is not the focus. I just want to see these records. And I've chosen to present the records like this because there is some interest to this. So I have an order 11 up to 15, which is for Portugal. 20-something is for Bulgaria. 30-something is for Ukraine. 40-something is for Greece. And then all of these numbers have different sizes, okay? So this one starts with a lot of zeros, a bit less zeros, a bit less zeros, etc., until you get smaller zeros. The reason for this is that I can add all of the numbers together, and then they will still be in a separate location, so it's easier to debug, okay? Let's have a look at how we can actually see all of this in detail. So if I try to do a group by, I will actually see Portugal with a lot of zeros, Bulgaria, etc. But if you add them all together, you get 15, 15, 15, which is the adding for each of these. So this is practical for us to understand which of the records we're actually seeing if we want to. Let's say we had thousands of records, this would be easy. So this is a typical trick that you do in demos so that you can understand the things that are happening. But we'll focus on Portugal and Bulgaria, which have a lot of zeros, and see most of this. Anyway, let's create a table for managers as well. So you get a manager ID, you get a country ID, and then you get an information whether the person is a global person or not. So let's create this and do a select, okay? And by the way, this is this one I'm not going to use. This was for my computer. I use this one for Power BI example, but in this case we're not going to need it. But we're just going to use these here specifically. So again, we have a global manager. This is by alphabetical order, but we have a global manager which has access to everything globally, and then we have one for each specific country that do not have access to global access. Okay, so we'll see how this works. Okay, so first of all, what is row level security? I haven't really explained this, but this is the part that I explain exactly what it is. So let's say you have a table with 1 million records, and you have records. Let's go back to this one. You have records for Portugal, Bulgaria, Ukraine, Greece, etc. You say that the manager is allowed to see everything, right? The global manager is allowed to see everything. But then you say that the manager for Bulgaria, the manager for Portugal, will only be allowed to see the records that they have. Now, in a classical sense, in most SQL worlds, you would probably use just a normal view to see these things, and then you say where view is equal to the country of the person, etc. So you could define limitations in terms of permissions using a view. The problem is that sometimes you don't want to use a view, you want to use the table directly, and especially for writing, for instance. And if you are using the table directly, there is a security concern that people will see the records which do not belong to them. So this is a problem at the application level, and it's a problem also at the database level. So anyway, we'll have a look at how to fix this. But first of all, let's do a small demo, and then we'll do the exact same thing using row level security. Let's try a small demo using a view. Okay, so we have that table on top. Let's try a view. The schema binding part is important, but I'll explain this just later on. Schema binding part is important, especially for views. This is useful, but this will also be useful for row level security, but we'll see that in a second. Now, the view is going to be a select star, basically. But why shouldn't you use a select star? Well, in any scenario in the SQL world, you should never use a select star. A select star is great for Management Studio, for us to just see some things, but for a production environment, for an application, using a select star will force you to read the whole table, or at least the whole records. And sometimes you just want, let's say, the country ID and the total, or something smaller, and there's probably going to be an index that can provide you just that information. So you will have to go to the index to actually find things quicker, and then you have to go back to the table and join to the actual content of the table and make everything slower. So if you just need 2 fields out of 100 fields, you just select the 2 fields, other than selecting all of the fields, select star, and then not using them. It's also very slow in terms of network, so you should avoid it, of course. But there's also some concerns about security. I won't mention that at this moment, but there are also other concerns about security that I usually present about, but just to give you an idea. Anyway, let's say we do something like a select star, and then we select from sales, and this is the table we just created. But then we specify a criteria that says where exists something, okay? And in this case, it's going to be, I could just simply say something very simple. We'll see the next example coming up, which is even simpler than this. But let's make this a bit more complicated, because it's important to show you a possibility. So we just want to guarantee that there is a record that associates the username of the person. Okay, so m.manager_id in this manager's table, and you open the manager's table using that specific ID. So suddenly you know which manager it is. You get one record for the manager. Let's say it's me from Portugal. So I get this record inside of the parentheses up here. Okay, and then what I do is I specify that my country ID in the manager's table has to be the same as the country ID in my sales table somewhere on top, the one that I really want to see. Okay, or if my manager is a global manager, then I'm able to see everything. Okay, so if this tag here says global, then I'm able to see everything. So this is a simple criteria, but this one uses a lookup table so that you can parameterize this in a table. This is usually the best option. You can do this manually if you want to, but if you want to scale this, if people go in, people go out, etc., it's probably correct to do this in a table. Now remember that these things about row level security are not built-in permissions that you have in SQL Server. You have the select permission, insert, update, delete. You even have permissions for column level security, which are the permissions that each column. You want to say that you deny select on, let's say, a credit card column, because you basically don't want people to see it. Only a few people have the allow permission or have the grant permission to see that specific column. Okay, everyone else has a deny, to forcefully deny access to that credit card column. But in this case, those permissions are usually defined at the database level, so the database itself supports this natively. But these are not business permissions. Well, they can be if you consider each column individually, but those are just generic database permissions that most database SQL database servers support, any kind of vendor. But these specifically here are permissions that can never be defined at the database level. These are permissions that are defined at the business level. This is a business, right? So in this case, there's a business that says country 1, 2, 3, 4, and then you have to specify which countries you're allowed to see. Even if you want to, you can even add, let's say, Portugal here, and then another Portugal here, and then you specify that a specific person here that's actually from Portugal can see in Portugal and Bulgaria at the same time. So instead of one row, you add 2 rows or something like that, and do this in a proper relational fashion so that you can access the information. But in any case, the example is as you see it. Let's create the view. Okay, and let's see what happens. So we created the view first. This is easy. Okay, something you should never do, which is select permissions be granted to the public. But in this case, remember, this is just a demo. This is perfectly okay. Let's grant the permissions to the public, and then let's have a look at some of the things, but with different scenarios. So first of all, you have execute as the current user. This is me. This is the system administrator. Okay, I'm running this as my Andy, which is the database owner, system administrator, whatever, and I get nothing. But, you know, I'm in charge of the server. I should see everything, but I get nothing. This is out of the box. Why? Because the Andy user is not in the manager's table, okay? I could add an Andy user and add that user to the manager's table, but I didn't. It's my fault, okay? But let's leave it like that. I could do an insert here if I wanted to, but let's leave it like this, okay? It's actually better to leave it like this. So again, the current user, the owner of the thing, does not see anything. Now let's have a look at executing as a user manager global. This is the manager that's supposed to see everything. So here you have that permission is global is different than 0. Okay, so let's execute this. So this manager gets to see literally everything. So 20 rows with all of the contents. Let's try the next one, which is manager for Portugal, and this one only sees 5 rows. These are the rows for Portugal only, and then you have Bulgaria, of course. Also 5 rows. All of these are 5 rows, by the way. And then you have the not a manager. This is important because this guy that's not a manager will actually have absolutely no rows whatsoever. Okay, this is expected. This is a normal employee in the store. Okay, this person is a normal employee, so they're not supposed to access the information. You might even reduce this, so you can go into the query up there and say if this is not on the lists. You might actually find that the user has special permissions just for a specific store, not the whole country. So you can add more things here so that you can define permissions on a store level, on a country level, or on a global level. But of course, you just expand the query itself. But by the way, this query, remember this query because we will be reusing this query in the future. Okay, so this is very simple, right? So now we'll do something slightly different. Before, no one had access to that table, that's a sales table, right? The permission was granted at the view for the sales, okay? Not the actual table. The table didn't have any access. I've just recreated the table so you know the table was empty, no permissions. But now I'm going to grant select to public, and again, not a good idea, okay? Never a good idea in production. This is just a demo. If you really have to grant select to someone, do it to a role. Create a role that says managers, like country managers or something like that, and then grant selects on that table to country managers, okay? This will be more correct than to just give this access to everyone, because in that case you are trusting your row level security too much, and you shouldn't. You should protect as much as possible, okay? If these managers are supposed to see the table, they should have the select permission to see the table. If this is someone else who's not supposed to have permissions, they shouldn't even have permissions at the database engine level. It shouldn't even go to row level security, okay? So select permissions first. Anyway, let's grant permissions to the public. I'm not sure if I did this already, but let's do it again. And then, of course, I need to create a schema called UW access, and this is a different schema. So before I just created the schema, let's refresh this, by the way. Oh, sorry, this one, refresh. So I've created two tables, but I've created a schema called UW, which is the underwater company. Okay, but this one is UW access. You can name it whatever you want, okay? But the idea here is that you should have a separate schema just for the row level security functions, because you can manage this better in terms of security. It is highly recommended, not mandatory, but it is highly recommended. Okay, so let's have a look at how this works. Create a schema, okay? And then we need to create a function. So this function that you see here is, strangely enough, very similar to the one we saw before, right? So the select part also has an exist, etc. By the way, you don't need to use the exists. So basically, you could just go directly here. I could just remove the exists. So it's actually my fault. I've actually could have removed this one already, but still, it's okay. I've actually copy-pasted too much. I could just do select one from this and use this, return this one directly. Okay, but my fault. But let's not change the script. It works. Let's not change the script now. I will fix it before I publish it. Don't worry. Okay, I just don't want to risk it at this moment. But I've actually added too much here, but that's okay. But in any case, the content is exactly the same. Small difference is that the country ID is actually not here from the previous selects. It's actually here as a parameter. Okay, and you specify an at variable for the parameter, but then that at variable will actually be called on here. So when you call on the sales to actually apply the security policy, you need to create a security policy. You provide the field that you want to use as the parameter, and then this field here, which is in the table, will actually be provided here as a parameter to that function. You can try the function manually, so you can run the function and do a select function and then parenthesis value. You can see what's happening in the function. This is your function. You can try it. But in any case, the result here is going to be that it's going to test the country of the manager based on your current username with the country ID itself, okay? So you'll see things here, which is quite okay. So, but anyway, you create a function, and then you need to create something called a security policy. And the security policy, so the function is a general function. It can be used for multiple tables if you have more than one. But the security policy, each security policy applies to only one table, and one table can have one security policy alone with more than one content if you want to. We'll see that in a second. But you can add content to multiple tables if you'd like, okay? Actually, a security policy can be used on more than one table. The same policy can be used on more than one table. I personally don't recommend this. You can do this, but there is no drawback in terms of security. But I usually prefer to separate everything. It's more, let's call it intuitive, but there is no drawback in terms of security or anything like that. It's just a management issue, so it's up to you. But anyway, we need to create a security policy, give it a name, and then add a predicate. So a predicate is basically a function, and you add that specific function we created before. So this function here, you give it whatever the parameter is supposed to be. In this case, it's the country ID field on that table, okay? And then you say it applies to the sales table, which makes sense. It's the only one we're using. And this one is important. State is equal to on, because you can have the security policy and the state is equal to off. So that just means it's the same as not having the security policy at all. The object is there referencing the table, but nothing is actually happening, so it's not doing anything. Anyway, let's create these two. Okay, so this is easy. Okay, they do this, and then there is something where you can see things. By the way, before I do that, let me just show you this. So you have here add filter predicates, and the filter predicate and block predicate do things slightly different. The filter predicate is for the selects mostly. Okay, it's for the reading. Okay, the block predicate is mostly for the writing. We'll see this in a bit. Okay, I don't want to detail this too much at this moment. We'll see this lower down in the scripts, but just to give you an idea how this works. Okay, so but anyway, let's have a look at these two dynamic management views, which are where the information is about the table. So first of all, I have a manager validation policy, which is this one. Okay, some name, and then down here I've created this one 1212, so this is correct. By the way, I have a previous one in a different table somewhere there, I'm not sure where, from a previous table, but it's a sales filter thing that I've created a month ago, something like that. So this is a different one. The one I want is this one down here. And you have information down here that says is enabled is equal to true. That means that it is actually enabled. It's limiting the table. So let's say if I want to see the contents of sales, so let's say select top 100, I'll get nothing. This is expected, right? This is of course expected. But enabled is equal to 1. If you turn this off, so say state is equal to off, this will allow me to see content in this table directly, because everyone will be able to see it. But then again, you have the details. So you have the policies itself, which is the generic policy, but then for each policy, you can have predicates down here. And in this case, you have for the manager validation policy, which is the one we created, you have a manager validation predicate with certain information. And in this case, they specify that it's a filter predicate. This is most important thing, but you also have operations. We'll see that the operations are things like insert, update, delete, etc. And this can be before the operation or after the operation. We'll see that in a second. Okay, this processes things pretty much the same way as the logic for triggers, if you are used to triggers. So the triggers use the same concept, although in practice the implementation is nothing like triggers. Okay, it's completely different. But the concept itself of the after insert, before insert, actually, yeah, after insert, there's no before insert because the record is not there, of course, right? But it can be before update or after update, etc. So you can see all of these things, but we'll see this in a second. So you have the security policies and the security predicates, which is where you see if things are running or not. The is enabled is the most important one that you have here. Now let's try this again. And remember, we did this exact same queries, but we did this applying to the views, not to the sales table directly. Okay, we applied this to the view. So let's try this again. So again, if we try to see the table directly, empty. This is expected, of course. If you try to see as the manager global, you get 20 records, which is everything. So that's correct. So you get to see everything. If you are a manager for Portugal, in that case, you see Portugal. But remember, we are looking at the sales directly. Okay, we are looking directly at the table. So from my point of view as a manager PT, I will only be able to see things from Portugal. So from my opinion, I might just assume that the table only has things for Portugal and everyone else does not have sales. This is not true, of course. We will see this. It's actually possible to detect this with some security bugs. We'll see that in a second. It's important to mention, but let's have a look at the remaining ones. So for Bulgaria, you have manager for Bulgaria, 5 rows. This is correct. And then someone who's not a manager does not see anything. This is, of course, expected, but we'll see this. Anyway, let's try to disable row level security. Okay, so let's try to disable this, and this query here that we had before, now we can see it. Of course, this is more than expected, but let's go back to this and do the security policies and predicates. And in this case, somewhere down here, it actually says enable is equal to off. This is correct, by the way. This is perfect. Okay, this is expected. So now we'll try to see the not a manager. Okay, and the not a manager gets to see everything in the table. So the security policy is turned off. It still exists because you can see them in the dynamic management views, but this is actually not working. Okay, it's like, yeah, please don't go in there, but the door is open. So it's, you know, you can still access things. Anyway, let's have a look at a bit more. Okay, and let's say we re-enable row-level security. This is of course expected. Okay, and then the not a manager is not supposed to see anything, so it's empty again. So this is turning it on, so easy. Here again, turning it on. So this is the easy part, but we'll need this turned on to the next demo. Now, how does this work internally? Because this is also a matter of optimization, right? One of the things that you see before, let's go back to the top and see some things. What's actually happening is that for every individual record that you have there, you're actually running this function, okay? In theory, anyway, in theory. So every time, let's say you have 1 million records, you open this function, you call on the function, get a result, yes or no. So basically what this actually returns is a table valued function. So it doesn't really return yes or no. It returns record yes or empty records, okay? The reason for this is optimization. So if they return the Boolean or a bit, this would probably be simpler in terms of programming, but this is not what's expected for optimizational purposes, okay? So what you actually have here is you return 1 record, which in this case only has the value of 1, but it can be 0, it can be whatever you want. It just has to return 1 record with at least 1 column that has some value. It doesn't really matter what it is. It just has to return something. So if it returns something, that's great. If the exists part, so if this doesn't return anything inside, that simply means that, I'm sorry, nothing is returned, and that means that you return an empty table at the end of this function. That means that that record that tried to match with that function becomes empty. Okay, so you don't see that record. Okay, so in terms of security, you're not allowed to see that record. So let's go back down here. Okay, so let's see how this is actually applied in the real world. Okay, so in the real world, this is in practice. Okay, so if you wanted to apply this in the real world, let's say you wanted to do this in a different engine, not SQL Server, but something else that didn't support row-level security, the implementation would look something like this. You would have to say, let's say, select star to make it simple. This is just the username, so we can see the actual username. In this case, it's empty because remember, we are at the global level. But then what they will do is say something like where exists, and then do a select star from that validation predicates, so that table valued function. If a record was returned, then remember that this is actually comparing the value of this one with the value that's outside from the same table from outside. If this was matched, in that case, you would get the results. If it didn't match, you didn't get results. So in internal terms in SQL Server, the optimization actually happens something like this. No guarantees that it's actually exists. It can be a cross supply or something like that. I'm not really sure. But internally, this is equivalent to this. It's like a semi-join, okay? But of course, semi-joins by name don't really exist in SQL Server. So you can do the exists like this, or internally, they can optimize any way they want. But the reason that they allow that the return of the function itself is a table valued function, so it returns 0 rows or 1 row, is that because you can join this together with other ones and just makes this like a normal join. So internally, they transform this into a normal join. Let's enable actual query execution, okay, and let's try to see what happens. So they try to join this, and then you have the execution plan. So there's going to be a lot of joins going on here. Let me just try to show you this. And basically, you have some joins, semi-left join, etc. So you're trying to join some of these things together to actually get the result much quicker. This is much better than to run the function 1,000,000 times or something like that. So they do try to optimize this in a way where things are easier to do. In this case, you actually have an extra one here in a normal one on top. Let's try one on top, which is probably easier to see. So select this current user. Let's say this one, which already has row level security applied. And in this case, you only have one nested loop, which mixes these two together. One is the sales, one is the managers, but they will actually mix all of these together. Okay, the seek for the managers makes sense because you are only looking for one specific person, so you can search for this in an index. For the actual table for sales, which is on the top, in that case, you are actually going through all of the table. There is no where. We didn't define a where, so you just do a scan for the whole table. But then you try to join this with the left semi-join, so start on top, as long as something down here actually exists, okay? So they transform the row level security from a normal query that then just asks questions in a function to something that's a bit more reduced, that just joins two tables and makes it a bit more efficient, because the SQL query is, of course, much more efficient, right? But anyway, let's have a look at this, and this would be the same example. So let's say the manager global would wait a minute. Okay, so I forgot to add the select permission. And why is this important? Because in the row level security, things just worked, right? We saw that things were working okay. We didn't really care about anything. Things just worked. But because this one, I need to have permissions to access the actual function. Otherwise, I cannot execute the function as a different user. This function is owned by DBO. So I cannot run it. So in this case, let's grant permissions to select on that table valued function. In most cases, this will be an execute or something, but this is a table valued function. So so the permission applied here is a select. So let's see this. So in the first one, of course, this is easy. You have 20 records. For the second one, it's also easy. You have, of course, in this case, 5 records plus 5 records for the one in Bulgaria. So down here for the one in Bulgaria, and the not a manager does not get to see anything because there is no exists here in the managers. When you go inside to use this function, inside of this, they will actually call a manager's table. The not a manager user is not listed there, so they will not be able to see anything, which of course makes perfect sense. So this is how internally they try to optimize the functions. So because of that, I will give you some recommendations a bit later on down there, some recommendations on how to optimize this. But it is important to understand that when you run row level security, this kind of optimization can exist. So if the function is very specific, so every time you call on the function, you get something like dates, current dates, or you get something like calling something else with the information that changes on every time, that can take the function to be very, very slow, okay? You cannot optimize this and remove the actual select from inside the function and put it out of the function directly into the query and optimize it if it's very specific. In that case, the function needs to run as a normal function, and in that case, you need to run it 1,000 times, and the query is going to be 100 times, 500 times slower, okay? That's going to be bad, okay? So you want to keep the content inside the function to something that can be transformed, that can be optimized to something that looks like this. Anyway, let's have a look at the inserts, updates, and deletes, okay? And first of all, I need to grant the insert permission. This is the same for updates, okay? So this is the same for update, and delete's kind of the same thing as well. So I'll just have an example for insert. It's easy enough, okay? So we have one for insert. Remember that for each country, we only have five records for each, starting with number 1 up to number 5. But we'll try to add number 6 here at the end. So let's say I'm manager for Portugal, okay? And I get to see the records for Portugal, okay? And it's only 5 records, so we can confirm this. And now I'm going to execute as a manager for Bulgaria, who's not allowed to see things in Portugal, supposedly. But let me try to add a record for Portugal using the manager in Bulgaria. Now, this will actually allow you to do this, which is, oh, this is scary. This is not supposed to happen, okay? If you go to the manager Portugal again, you can get to see that now there is a record here, but this was added by the user which was from Bulgaria, okay? And this is, of course, bad. This is not something that you want. Let me say that this is, of course, a bit scary. But this was permitted because the filter predicate allows this to happen. Anyway, let's try a different option, which is now called the block option. And this is used to fix this problem. Now, first of all, let me just drop the security policy. I can just do the alter security policy if I wanted to, but let me just drop it because it's easier. In most cases, you always do a create. You don't really do an alter, because it's usually the typical scenario. Now, I'm going to use the same function. This can be a different function if I wanted to, one for reading, one for writing. This can actually be a different function for reading, a different function for inserts. For instance, I could allow anyone to do an insert, but then only certain people would be allowed to do updates. This is perfectly viable. Okay, so you can have different functions with different permissions, etc. This is all business rules, so you can define anything you want. But let's assume that this is a security policy. So I've dropped this one already, hopefully. Yeah, I've dropped this one already. And then let me create a security policy like this, which basically says that there is going to be a filter predicates on that table, so on the same table, but that filter predicate is going to have the country ID, the usual thing. I'm going to reuse the same function. It could be different, as I mentioned, but I'm going to use the same function for block, and that means for reading. For the first one is for reading. The block is for writing. Okay, generic writing. We'll see details in a second. Okay, so I've turned this on, and now I have something slightly different. Okay, and in this case, I have my manager policy here, which is okay. 1 second. Let me just increase the size of this so we can see it. 1 second. Okay, so this one is running enabled, but this one now, for the same manager policy, you actually have two things: one for filter, one for block. Okay, 0 is filter, 1 is block, so this is easy. And you might even have operations which is, let's say, after inserts, or before update, after update, before delete, etc. So you can add those kinds of operations to this as well if you want to. But in our case, the example is much simpler, so we didn't do that. But anyway, let's now try the same example. So let's first of all see the things that are happening in Portugal. And currently in Portugal, we have 6 records in total. But now let's add a record as the manager for Bulgaria, okay, which is not supposed to have permissions to read from it, so they won't be able to see it, but also not the permissions for writing now, because you have the block option. So suddenly there's an option, attempt target something, a block predicate conflicts, etc. Okay, so now we have a problem. It doesn't work. This is as expected. This is perfect. This gives you an error, a permissions error. Now let's try the manager for Portugal again, just to make sure nothing was added. Okay, and again 6. But now let's try the manager for Portugal to add a new record. Okay, now let's say I add record 18. Rows was okay. By the way, the reason you see 2 rows affected is that because the predicate also gives you some information. So you also process some things. So you see more than 1 row affected in terms of counts. This can affect your script, so please be careful. But in reality, I'm only inserting 1 single record. The problem is that when you execute row-level security, you get some extra results. So it's probably a good idea not to base yourself on this records affected results, okay, which can be deceiving. Let's call it like that, okay. But anyway, let's have a look at manager Portugal again, and now we have the number 8 here, which is what we expect. So the Greek manager could not, Bulgarian manager actually could not create the record, but the Portuguese manager could. Make sense? Okay, different permissions. Anyway, some extra information here that I wanted to mention. So you can just say something like add filter, which is normal, but you can also say add block after inserts, and that will actually show up in the dynamic management views. You can say after inserts, before update, after update. So update has the before and the after, right? And then before delete. There is no after delete because the record is already dead, right? And there is no before insert because there is no record there before, right? So in any case, you have those 4 operations. These are, as expected, almost the same as the ones you have for triggers, etc. So I mentioned that these were very similar. But in any case, after insert and after update can prevent the users from updating rows to values that violate the predicate. So to insert something that's wrong, and before updates prevents the users from seeing the records that you are not allowed to see. So as an example for this is, let's say you have something that you want to convert from Portugal to Bulgaria, for instance. If you start in Portugal, if it is a before update, you can see the one that says Portugal, but the after update will not allow you to change the country to a different country. Okay, and that just blocks that altogether. In a normal scenario, you just say that it's a block predicate for everything before and after. So that guarantees that you validate the record that was before, which is your record. You need to make sure that the record is yours, and the after. An example of this is the other way around. So let's say that you are the Bulgarian manager, and you take Portuguese records, and then you change it to Bulgaria. You take over it, you steal it, for instance. Okay, so if you steal that record and you are using after updates, it will work, because the validation validates that after update things will work. So this is not a good idea. But you need to run the before update to make sure you're not touching a record which is not initially yours. Typically, a scenario might be you say before updates, the record is yours, but then you pass it on to a different manager, some other manager for some reason, and that could be an acceptable operation. So in that case, you just use the before updates, you don't use the other ones, okay? And some people might be allowed to have deletes, others not, so it will also depend. By the way, all of these 1, 2, 3, 4 operations plus the filter operation can be done with different functions. So all of these have different business rules associated with them. So you have different kinds of scenarios. In most cases, if you just add the normal block without the detail, in that case, it's everything. So it's all the 4 operations that you see there, but you can be very specific into the things that you want. Anyway, a few informations here before we continue. So schema binding. Schema binding is important because if you use schema binding when you create these things, it guarantees that you don't need to specify any permissions on any table that's referenced inside the function or the function itself. So you don't need permissions. This just works. So you notice I didn't add permissions to the row level security, but I needed to add a permission when I try to do if exists, where exists, and then try to execute the function, right? So in that case, you don't have to have schema binding, but if you don't, you have to manage permissions by yourself. Not really recommended. Also, in a normal table that has row level security, the select insert update permissions that come with the SQL engine also apply, so you have to be careful. If you don't have select permissions, you'll never be able to use row level security or anything like that. It doesn't even reach the function. Same with insert update delete, and even the references one I didn't mention here, but even the references one also applies. Let me just add here just for completeness, references. Okay, done. Okay, so the predicate function, which is the function that we use, doesn't really care if you are DBO or a member of the database owner. And you saw that I ran as Andy, which is the owner of the thing, and they didn't care because I was not on the list. It's a VIP room. You have to go in, you have to be on the list. If you're not on the list, you can be the president of the country, you're not getting in. Okay, it's as simple as that. So setting state is equal to off basically has no side effects. It completely turns it off. But the policy is still there, so you know that it exists. You can turn it off and turn it on at any time. You cannot change the table or predicate function if the policy exists. So if you try to delete the table, but the policy exists, there can be issues. So you have to delete the policy first. On top, I actually have the drop scripts. So first of all, I drop the policies, etc. Then I drop the function, and then I can drop the table. So I have to drop these things in sequence. Otherwise, they will just be aggregated, especially if they use the schema binding, they will be aggregated and it doesn't work. I also mentioned that a separate schema just for the functions is important. And then let's talk about permissions very quickly. We have about 5 minutes, so hopefully I'll still have time to do a quick demo, if that's okay. But anyway, permissions for row-level security. You need to alter any security policy permission. And you also need permission to alter on the schema where you're creating the functions. Admin users don't really need the select permission to create these kind of policies, so they might not even be able to see things, but they can still create the policies. And the select and references permissions are needed on the function to be used as predicates. As I mentioned, if you are using the schema binding, it's not much to concern, but if you turn it off, you need those permissions. And you also the table. Okay, and you also need reference permissions on every column of the target table that you are going to use for calling as a parameter for that function. Finally, the user DBO will have all of these permissions for alter, security, etc., but including the select permission by default, of course. But if the function itself does not have the necessary thing that say that Andy is allowed to see things, then I'm not allowed to see things. It doesn't have to do anything with the engine. Okay, there's also some security breaches. I'll show you this in a second because I think we can have just 2 or 3 minutes to do this. Just to quickly mention, row-level security doesn't do well with indexed views. It works okay, but you can use it. But if you have it enabled row-level security, the indexed views will actually copy all of the original information. So this basically is not good for row-level security. Partitioned views specifically do not work well if you are using the block predicate, so that they do not work well. With column store, things are okay, but the plan, the query plan will change, so it's an optimizational issue. Change data capture, change tracking, and temporal tables have problems in terms of leaking. So in terms of security, they can leak to other places and see the original information, same as indexed views, basically. But in the case of temporal tables, the original table is okay, so it has row-level security, but the history table that has a copy of everything that happens, you need to apply row-level security as a new security policy as well. So you have to apply the policy in the 2 tables to make it work. Otherwise, it's all okay. You should use schema binding whenever possible, otherwise you have permission issues. In-memory tables now support this, but if you want to use this, you have to compile the function with native compilation option. Okay, this is important. By the way, there are links to this, so feel free to have a look at this later on if you'd like. Full text indexing is okay, but it has some issues in terms of performance, etc. File stream simply doesn't work. So it doesn't swim well, it doesn't work. Polybase using external tables works really well, but only for Synapse Analytics. We'll see Synapse Analytics in my next session in about an hour. And of course, if you have a function inside that uses recursion, type conversion, a lot of joins, etc., or has some long operations, etc., this will affect it. So try to do a function that can be transformed into just a single join operation on the outside, as we saw before. Okay, it's almost time to go, okay? But before we do that, I really wanted to show you how to hack row-level security, do it quicker. So this is a demo that comes along from a different example that I do with hacking SQL Server. Okay, so I'm going to run this, but I'm going to run this on a different server. So in this case, 2019 works well, but 2019 doesn't. So basically, I've created a table with James Bond. This is the same as I use for the other demo, but for completeness, I wanted to show you that this actually exists. So it's going to be just 1 or 2 more minutes. I think that will be okay. And again, I could create a view, etc. So this would be the exact same thing as before. But in this case, you can see that the view is just where username is equal to the name of the owner, so Roger, Sean, etc. Or it can be user is equal to M, so you have the M user showing up here as well. So you can use that one, which is the boss, and she sees everything. So of course, this one is easy. So you create a view with schema binding, and you try to see things as the M user, so you see all of the rows. But if you try to see things as the Sean Connery user on the view, of course, you only see 7 each, and then in the queue, you don't see anything. This is expected. Now, with row-level security, of course, you can see much more. So I will try to show you this and then see the results as well. We've seen these results before, so I will skip this very quickly. So you have this one. This one is 26. First one is 26. Second one is 7. And the other one is also 7. And then the last one, which is Q, is 0. So this is expected. But now let's have a look at how to hack this specifically. Okay, so let me just go through the scripts to make sure everything's okay. And then security is equal to 1. So first bug is trying to hack this. And let's run this again so that I just have this results. So the first bug is that you know that there are going to be 26 rows. You are Q, you don't have access to anything. You know that there's going to be 26 rows in these things. because you go to sys partitions and you see the rows there. You see 0, but you see in that table that there's going to be 26, so you feel deceived. And if you are Q, you get some tools and try to fix the problem. So basically, let me show you. Before, there used to be a problem up to SQL Server 2016, where this could be used, and you could divide things by 0, so 1 divided by a number that exists, which is number 7 here from 1969, and that would actually exist, and then that would be an error. But if you enable it again, this is not an error anymore starting 2016, even on the CTP. But if you change it around the bits, you can actually get to see the errors running in this one. So you have a division by 0 error. You have 0 records, but something did happen. So this automatically detected that's at least one record that has the year 1969. This is how you hack it. Okay, you divide it by 0. This is how you hack it. Now, one important thing to mention: this in 2019 and in SQL database, this doesn't exist. This is why I added this database here with 2017 so that I can show you. And if you are curious about this, I've actually created a row-level security hacker tool, which this one, I'm sorry, I cannot provide the copy for this one, but I can provide the scripts for everything, but not this. So let's try to load the data. So initial load with all of the data types, get the IDs, and getting the IDs is doing division by 0 26 times. So this is hacking already to find the IDs. So you try to divide ID -1, ID -2, ID -3, and then try to see if that is 0 by 1 divided by that, and try to hack it. The year is also easy. You get the IDs for the year. You also divide by 0. The strings are a bit more difficult because these are really random. You can join 2 tables together and try to hack it. Technically possible, but the easiest way to do this is to try 1 character at a time. So you try to divide the character by the sequential ASCII number of the characters, and then try to find it. So you can tell that this is very easy to do. So this happens in 2016 and 2017. Nowadays, 2019 and SQL database in Azure do not have this problem. So just make sure you have the most recent version of all of your updates and things like that. We are running out of time, so I'm getting a message we're running out of time. So let me thank everyone for being here. Okay. Thank you, everyone, for being here. And I'm not sure if we have any questions at this moment, but in any way, let me just leave you my contacts for anything that you need, okay? And you, of course, have my contacts here. Just go to andy.pt. You have a link to my LinkedIn and Facebook and things like that, so feel free to join. And of course, let me just mention one other thing. In 1 hour, so in about an hour, I will be presenting a session on Machine Learning is Full of Stars, an introduction to machine learning on track number 1, by introduction to machine learning itself, and then see how you can use this on the Microsoft world using Azure and using SQL Server and things like that. So join me in about an hour for the last session, and this will hopefully be fun as well. Okay, so I really want to thank everyone for being here and watching my session. Stay safe and have an amazing event. And by the way, thank you very much for being the country where I've presented the most sessions so far. It's up to at least 25 now, hopefully 26 within an hour. And hopefully next time I will be there like I was in October in SQLSaturday in Sofia. But hopefully I'll be there next time to get some food as well. So thank you very much, everyone. Feel free to contact me at any time. Okay.
Thank you very
all.
much, Andre. Thank you.
Okay. Thank you very much, my friends. Okay. Have fun.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative, from TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com.
So our next topic is quantum computing explained with demos, and the presenter is Damian Videra.
Hello, can you hear me now?
Yes.
Yes.
Yes, that's great. So now I can now share my screen. That's great. So let me just connect to my presenting laptop. I would need this very much. And right, because you know, quantum requires some kind of preparing some drawing, and I will have them just in a second. I wonder which screen can you see? So could you please tell me which one is presented?
Right now we see your presentation.
Drawing and audio. And now presentation. Perfect. That's what I wanted you to see. And let me start then. This will be all about quantum, and I would like to really show you a quantum experience today, which means I will show you some demos about quantum computing. That's the goal of the session. So, first of all, thank you to our sponsors that we can meet today during SQLSaturday in Plovdiv. Of course, I would like to be there with you. It must be a beautiful place today now in December. We have a little snow in Poland, so I hope you have even more snow in Bulgaria. But I can be wrong. It could be a really hot place today. I don't know. Really, I don't know. So let me go just few words about me. I'd like to concentrate today about quantum, but let me introduce myself. My name is Damian, and I spent all my time in Poland. That's where I live, and I've been Microsoft MVP for 11 or 12 years. I think it's I've just finished my 11th year as a MVP, and what I do is I really love data and deal with data, and I found particularly the quantum computing like is the future, because I spent my last time in machine learning and AI. So I see that at some point we will really reach the the limits, and some operations, some algorithms require to do a step forward. So we really need to go somewhere in which let's say classical or the entire neural network, they will just not be enough, not be sufficient. So doing the next step is really something very, very necessary. And people are, of course, are keen on quantum computers, and they really want to know how quantum computing might help. And this is the session I'd like to do today. So first of all, I'd like to convince you why we should care about quantum computing, and how it is even possible, and how quantum computing might help us. Those will be the first part. So I need to explain you first very basic quantum computing things, just how they work, what are the basics. So unfortunately, there will be a little bit of math. Then I tell you about the resources you can, tools and resources you can use. And I really going to connect you to the real quantum computer, which will be IBM quantum computer. So let's move forward, because I'd like to show you the code, show you the basics. But you know, quantum world is a really strange place to be, and we are somewhere in this quantum world. But you know, quantum scales are the scales that are more, let's say, they are smaller than we are, because we are operating in meters and kilometers. This is the scales we live. Also, the time scale, we are, operating in normal days. It's like seconds, hours, minutes. And this is not the place when quantum effects are really observable in, let's say, in naked eyes. I think we can, you can explain that some, chemical reactions or physical reactions happen because of its quantum nature. For example, if there is really hot in Plovdiv today and you can see the sun, because I can't, we have a very cloudy day. So the way you can feel the hot from the sun is due to the quantum effect, which is related to some radioactive reaction, which is called beta reaction. So this is because of, and the only way you can explain it on a physical level is due to the quantum nature of the surrounding worlds. And of course, you can think about it that we are not, the scales we observe is not enough, because we also see the stars, we also probably can see the nearest galaxy, which is Andromeda galaxy, and they live in different scales. But somehow everything is connected together. So the micro scale in which we see the quantum effects, and of course the macro scale, which is the galaxy, with us somewhere in between. So this is how the world, the entire world looks like. So we would like to go into the quantum scales. So the molecules and even smaller, this is where the effects are really observable. And we'd like to utilize the possibilities. And you know, the very basic, because the world is really not that complicated on that levels, but it's really strange. It's something totally different, what we can observe in our life. And the two most, crazy effects are the building blocks of quantum computing. I mean, superposition and entanglement. Entanglement is so crazy that even Albert Einstein didn't believe it can be true. So think where we are going to go today. And those are two building blocks of quantum machines, quantum computing. And there are different quantum computing models you can see, and you can read about them. We will be talking about quantum circuits because I think this is the easiest model you can imagine what we are going to do, because we know how to program things. So we can do a lot of T-SQL stuff, maybe C# or Java coding. So you know how the program should look like. And quantum circuit is close to what we think the programming is all about. And there are different models. And for example, in Azure, there will be an offering, public offering of quantum computing, which is built on topological quantum computing, little different bit of little different model. You know, that's the first slide, and I'd like to show you the math, because we have to start somehow. So let me switch to my to my laptop, which is this one, and I'd like to introduce you to the quantum weirdness, because this is how we should understand it. It's something which is totally different from our world. And you know, let's start with our computing, the computing on a very classical computer. You have laptop, you have cell phone nearby you, and you know that when we are starting computing, we are thinking that the very basic operation is the basic operation you can do, and this is operation like 0 and 1. Something is green or red. You say yes or no, and this very basic operation can be noted as on a very basic level, on a bit level. So we have classical bits, and but you know, this is the representation we can understand, but we have to deal a little bit math. So if there must be a way in which you can try to understand it on a algebraic level. So in two-dimensional space, you would like to say that how can I draw a bit number which expresses 0 and a bit which expresses 1? So the 0 and 1 state. And in math, we can imagine that you can code this information that way. So this will be bit 0 and 1. So you see they just pointing in different direction. So that could be bit 0, and this could be bit number 1. Because if you think about you know, a coordinate in this coordinate, and we can say this is x and this is y here. So that could be x and y, x direction and 1 direction. So you see, to encode bit number 1, I have to go 0 in y direction, so 0 in this direction and 1 in this direction. So this is how those bits looks like. And now let's do something totally different and express how we can draw a quantum bit. So there must be a difference between them. And it turns out that the quantum bit, so this is a classical bit, let's call them bit. And now let's draw quantum bits. So they are called qubits. So we can say that there is a qubit which expresses the value 0, and the qubit that expresses the value 1, and they are coded that way: 1 and 0, and 0 and 1. And now it's a puzzle because they look exactly the same. But think about how I call bit, classical bit. I told you that the classical bit can be 0 or 1. You cannot have both. But in quantum world, the state of the bit can be 0 and 1 in the same time. And now you see, things are getting complicated. How you can be 0 and 1 and everything in between in the same time, that's complicated. So qubit means that you are 0 and 1 in the same time. So you can say that I can have all positions which will be allowed in this is a fragment of a circle. I could draw it as a circle, but you know, I'd like to make it simple. So you see, it's 1/4 of the circle, and you can have value with equal probability, which will be position of that circle. The only the only assumption you do that the length of the vector must be equal to 1. So what does it mean? If I plot a qubit, I will make it a little bit bigger. So I will make it like this. So that will be our x direction and y direction. And you see that bit which is 0 will be like this, and bit which is 1 will be like this. So if you measure a length of the bit, so you know, because now we are going into math, so those are just vectors. So vector like this, which has length 1, this is the state 0, it has length 1, and you have vector which is like this, it has length 1, and this is vector number 1, this is this one, yes? So qubit can be everything in between unless it has length 1. So you can say that this vector, and I will draw it like that one, it has a certain probability because we measure them with probabilities. If it has a vector, if it has a length 1, then it expresses a probability of some state which is between 0 and 1. And as you remember, I told you that qubit can be everything in between unless you measure it. Once you measure it, so you perform a measurement, it turns to be like a classical bit. But during the calculations, you can carry much more information which is in between. So you can perform a lot of calculations, you can carry a huge number of operations unless you measure the bit. When you measure the bit, it has to collapse. So physicists say that the bit has to collapse to a value 0 or 1. But you know, the expression of qubit in a physical world is that you have to express two-dimensional space, because now we have only a 1 bit, so it can be 1 and 0 at the same time. So the expression is that we express it that way in mathematical world. So it is 0 and 1 in the same moment, because you know how to calculate a length of the vector. So you have to take the x, this is x and y. So you have to make a square root of x and y. So you have to make it to the power of 2 and perform square root. And you know, let's go to the primary school, and you know what it is. This is if you have a triangle like this, x and y. So what we are calculating is that length, and this is Pythagoras theorem. And you know where it is all started. It all started in very, very old days. And the algebra you know from your university, and it all started in primary school, it also applies in quantum world. This is exactly the same algebra, maybe on a little bit more complicated way. But you know, the way you have to start in quantum world, you have to be able to express that your qubit, before you measure it, it has an equal probability to be in a state 0 and a state 1 in the same time. So you have 50% of being 0 and 50% of being 1. This is how it is expressed. And you know, you can reduce this qubit to be something like this. This is 1 over square root 2 of 0 and 1. So sorry, you have to express, it has to be equal probability, so it cannot be 0. It has to be 1 here. But we know that this works that way. So it's a little bit different state. But remember, this is during processing. Once you finish your calculation, this function, the probability has to be 1 So I mean, during processing, the probability is always 1. So this is the probability. But after the process is done, the qubit will be in that state or in that state. So this will be 0. Sorry, this will be this is 1, and this is 0. So after calculations, you can observe the normal thing, 0 or 1. But during the calculations, during the processing, you have 0 and 1 in the same time. And this is really powerful, because if you have 16-bit qubits, you can encode 2 to the power 16 of states, which is a huge number. This is a really huge number. And I can tell you that you can imagine how, and I'm just trying to move my mouse to another monitor, because I wanted to show you how you can understand that, you know, something can be 0 and 1 in the same moment. And let me show this to you, and then I will tell you how we can perform a superposition in code. So let me do it that way. So think about this. I'm presenting this one. I hope you can see it on the screen. Think about a coin, and you toss a coin, and imagine that the coin, you know, at the moment, and the coin is a two-state element. It is head or it's heads or tail. So when the coin is moving, when you toss it, can you tell me whether it is heads or tail? I think it's not possible unless you catch the coin. If you stop the coin, so this is when you perform a measurement and you see how it looks like. In that case, you can say that after measurement, so once you catch it, it is head or tail. But when you move it, when it is, you know, when it is moving the coin like this, you cannot say whether it is heads or tail. So this is how you can imagine the quantum world can be. And as you see, when I rotate the coin, you can see sometimes it is head, sometimes it is tail, and sometimes it is even a little bit more heads and a little bit less of tails. But at the end, it can be only one or the other state. So this is how we think about quantum. And when we go to this quantum idea, it turns to be that if you would like to encode this state, so the state of superposition, so to be 0 and 1 in the same time, this will be called a Hadamard gate. And you will see this operation just in a moment. So you will see that in order to make quantum world possible, you have to apply so-called Hadamard gate. It's an algebraic operation. It will look like this. So you will see it will be 1 over square root of 2. And it will be a matrix operation, and it will look like this. And this will perform a bit to be a qubit in a superposition. So after it will be 0 and 1 in the same time. This is one of the most important operation. And quantum gate, it's just operation like if you can think about it in a classical world, it will be just like a multiplication or division. It's just a very basic operation in quantum world. It's called a Hadamard operation and a Hadamard gate. There will be other operations, and I will show this to you just in a second. But the second most important, concept, which is so crazy. If you think that superposition is crazy, so now please be concentrated, because this will be crazy. Superposition is a pretty normal thing, because you can also observe it around you. If you observe just, a sunlight or another type of light, you can still think that, waves can be a nature of waves, any wave you can imagine. So music wave, light can be also imagined as a wave. So you still can perform superposition nearby you and observe it in macroscopic world. Just pick a stone, 2 stones, and drop them into the water, and you will see superposition. but entanglement you will not see around you. And it is so crazy that, as I told you, Einstein thought that it could not possibly be right. And I will tell you why. And without superposition, you cannot imagine quantum computing and quantum security. So how entanglement works? Physicists can do things like this. So imagine that there is a physical machine, which is like a black box here. I don't know how they called it. This is something that can produce. We can call them atoms or molecules, and we can even say that those can be electrons. But electron is a not good. It's a not good medium in quantum computing because it has charge. So that if you plot an electron, it has negative charge. So you can intercept it just by applying a positive charge on it. So the total charge will be 0. So you can intercept it. So it's not a good medium in a quantum world. There are other possibilities and other molecules you can use. But imagine that as of now we will be talking about some some particles that are created, and it's not really important what kind of particle it is. But imagine that there are two particles created in one quantum event. And physicists can do it all the time. It's not complicated on this level. So they know how to do this, and they produce millions or billions or events like this per second. So it's not, you don't have to have unnatural power. It's like something very basic for them. So they can create in this physical machine. It's like a physical box. And you can create two particles, particle 1 and particle 2. And those particles, and now I believe you know something about physics, and you know that particles can travel with the speed of light. So if one particle goes that way, and the other particle can go that way, so they can never communicate, because they travel in a speed of light in opposite direction. So, and you can imagine that you can perform a measurement somewhere here, and it will be like, it can be like 10 meters, or it can be a kilometer, or it could be several light years later. But if you perform measurements in this point, and perform measurements in this point, that means that those particles cannot communicate together because they are moving in different directions with the speed of light. And now there is a thing which is crazy to explain. But imagine like this, that internally a particle can carry its state. So the state can be 0 or 1 in the same time. So they are already in superposition, and they are entangled, which means they are created in the same event. So imagine that there is a person, and there is a person which is a physicist called this person Alice, and there is another person, and they call this person Bob. So imagine that Alice can take this qubit, and Bob can take this qubit, and they really can take it. So entangled particles, let's call them particles, entangled particles can be in this entangled state almost forever. So you can imagine that if this particle could be bigger, you can take it and put it on your desk, and this particle will be like a shining in your desk. They will be constantly in this superposition. And now remember, they cannot communicate. And now this is the moment when the strangest things is going to happen. Alice, so she has her particle here. So the particle traveled here. Bob has his particle here. So this is Bob's particle, this is Alice's particle. And now Alice is going to reveal what is the state of the particle. And Alice can see that the particle state, what would you like it to be, 0 or 1? And you choose to, for example, you decided and particle measured the state, sorry, Alice measured the state of the particle, and the particle says, I'm 1. And now, this is the weirdest thing you can imagine. In the same moment, without any delay, and without any possibilities of communication, the particle of Bob collapses to zero. Without any communication, they can be separated with infinity distance. And this is how quantum security can work. Imagine that B is your bank, and they will generate a key for you. And they send the key that way, and they have also, so this is like your bank account. B is your, in this moment, your bank account, and you have the key. In the same moment, you open the key, you have access to your account, and no one can intercept it. This is how strange quantum communication can be. You know, this is so strange effect that Einstein thought there must be a different explanation, and he thought, and it is, you know, his thinking was really very logical, because what Einstein thought is that those two qubits, when they was created in this single event, so internally they carry its state. So it works that way, that imagine that you have two boxes. This is like a box number 1, and this is box number 2. And you have two balls. One ball is red, and the other ball is green. So the state of the balls are known up front. So if Alice take this ball, which is green, and Bob takes this ball, so Bob has red ball. So in another story, if Alice knows she has green, in the same time, she has to know that Bob has red, because there are only two possible states. And that was explanation from Einstein, that this value, this information is hidden inside the particles. But then it was experiment done by Mr. Bell, very famous physicist. And he told that there is no hidden information, because we don't know the state. The state can be 0 and 1. So Alice could have measured 1, but she could have also measured 0, and in the same moment, the state would be 1 on Bob's side. So there is no hidden information in the particle. They are really entangled. And this is the crazy part of quantum computing. And now you will see that to build this entanglement state, I will draw this in a moment for you, but you would need to perform Hadamard operation, so Hadamard gate, to perform a superposition and to apply another operation, which I'm going to explain you in the moment now. So let me switch to my presentation. I will take it to another screen to not to bother me, but let's move forward now, because what we need to do next, I need to tell you about tools and resources. So you know what I'm going to do. I'm going to show you the code, first the code on the Jupyter notebook for the first time, and then we go to another framework and programming language, and I will use Qiskit, IBM Qiskit language. Microsoft have Q#, which is some kind, you know, those are, all those languages are very similar to, like you do object-oriented programming. So you see, we will be creating objects in Qiskit, but the very basic language is like an assembler, is called QASM, which looks like a classical assembler. So if you have an assembler background, you will see that the translation from Qiskit or from Q# in Microsoft, it will be like to this very assembler code. We will be creating code which you see on the left. So we will do some object-oriented programming, but this will be later translated to some kind of circuit, to some very basic operations that are can be really played on quantum computer. And before we go to this coding, you need to know that there will be always 3 elements. You have to have data, and data means qubit. Like data in classical world, this is bit. In quantum world, those are qubits. And then we will do operations, and the operations like multiplication, division, whatever you do in a classical world, they are expressed on some called quantum gates. So this is how the operations are called in quantum world. And maybe you can remember that I told you that there is a quantum operation which is called Hadamard gate, and it looks like this. And you might be surprised that there is a -1 here. So the matrix is 1 everywhere apart from -1 in one place. And this is connected to the quantum gate transformation, which says it has to be unitary. So you have to be able to reverse the operation. So you have to be able to do reversal, which means that you know the original state. So if you perform, you have a bit which has state 0. If you apply Hadamard gate, it will be in superposition, so it will be 0 and 1 in the same time. But if you apply reverse operation, then you reveal the initial state of the bit. So you will know whether you started from 0 or 1. Not all operations are reversible. Also in our data world, not all operations are reversible. Like if you perform summation of if you perform average, you have no idea how it all started. Yes, it's not a reversible operation. And of course, you know, when we have data and operations, at the end, we will measure the state. So it will be 0 or 1. So let's do this. Let's go quickly to Jupyter Notebook. So just to quickly mention what we can have. We have a very basic state. I draw this for you. We have a state 0 and 1 coded that way. And you know, then now the strange thing happened, because to imagine how quantum world looks like, we have to imagine that we have operation like tensor operation. This is tensor operation, which means you have to take the first value from the first qubit and multiply it by the entire vector. So 1 times 1 gives you the 1 here. Then you multiply 1 by 0, and you have the 0 here. Then you take the 0 and you multiply it by the entire vector, which means you have 0 on every possible combination. This is how you can carry on 2 qubits, you can code 4 possible information, and you have all the states here for the entire qubit. So let me tell you how you can create the superposition, and this is how Hadamard gate is expressed. So you see, if you have the qubit, the bit at the beginning, it's a regular bit. If you have the value 0 and you apply Hadamard operation on it, so Hadamard transformation, it is encoded like a plus state. So it is like a superposition which was initiated from the 0 state, but it is coded, this is the Hadamard gate. If you do this on a state 1, it will be superposition, but we have to say that it is like a minus sign, because we would like to know that it was originated from the state 1. So now let's play with quantum coding. You have to install Qiskit from IBM side. Those are their libraries. So you just have to install it on your local computer and import the library to Python. If you have this, so if Qiskit is in place, then you can create a quantum circuit. And I have two qubits here, as you see here. So then I will run the quantum circuit. So I will build them from 2 qubits. And I'm going to apply Hadamard operation. So Hadamard gate on qubit number 0 and qubit number 1. And once this is done, I will draw this circuit for you. So you will see how it looks like. So take a look. This is the circuit. So you have a qubit 0 and qubit 1. Don't mess this with their state. We don't know what the state is. And after Hadamard gate, they are just in superposition. So they are 0 and 1 in the same time, but they can be different. And I am going to tell you what is the probability for the qubits to be in different states. So now I am going to run this on a simulator to show you the probabilities. So take a look. I created simulator right now. In a moment we switch to regular computer, but I would like to give you the impression that you can also perform the operation on your local machine. And just from knowing the physics, you know what results you should expect. So I'm going to run my quantum circuit on this backend, which is a simulator right now, to show you the probabilities of each state. So take a look. If we have two qubits, so we can encode 4 possible states. And this is the probability when you do the calculations. What is the probability the bit to be in a different state? So this is the state, for example, 0, 0, and length of the vector is, the probability is 25%. And by the way, I have forgotten to mention that if you like really to play a quantum computation, you have to go back to the complex numbers. So you have the imaginary, you have the real part and the imaginary part of your number. Hence, this is more complicated than I plot it on the in my tablet, but it expresses what you have to understand from linear algebra. So if you perform, this is a vector in 2-dimensional plane. If you calculate its length, it will be 1. So the probability is length of the vector, it is 1. So now it has the same probability to be 0, 0, 0, 1, 1, 0, and 1, 1. This is 25% of each state. But if you perform the calculation, it has to decide whether on one of those states. So you will have 100% to be 0, 0, or 0, 1, or 1, 0, or 1, 1. But after calculation. During calculation, it has all the states in the same time. So if you have 3 qubits, I mean 3 elements, of course you can encode up to 8 states, and you see those are the probabilities. At the end, you have to choose one of those 8 states as a result of your calculations. And now I have to tell you about the second important gate, which is called CNOT, or control NOT, before we jump into the computer. It behaves that way, that in the following way, that if you have a control input, if the value is 0, you are not changing the value of the other bit. But if the control bit is 1, you are flipping the second bit, the target bit. It's called target bit. So if the bit was 0, you flip it to 1. If it was 1, you flip it to 0. This is how it works. So this is so-called CNOT gate. And now we have to create this strange quantum entanglement. So let's do this. I'm taking 2 qubits, and I also create 2 regular registers. This is how I'm going to measure it. For measurement, it can be something that can measure 0 or 1. In a physical way, it can be expressed like you are going to measure a voltage or so. But in our in IT world, we're just going to measure 0 or 1. So those are so-called classical registers. So let me create this quantum circuit. It has 2 qubits and 2 regular registers to measure its state. First qubit is going to be expressed on a Hadamard gate. So this is the first transformation. And then we are applying the CNOT gate, which I explained you previously, to perform entanglement. So these 2 qubits in a moment will be entangled. Now, first qubit is in a superposition, and then you do the entanglement. So those 2 qubits will be like created from the same event. This is it. And now we are going to measure qubit 0 to the first register and the first qubit. So the first qubit to the first register, and the second qubit will go to the second register. So we have to measure its state. And this is how it looks like. So take a look. This is the Hadamard gate. This is the CNOT gate. So this is entanglement. This is entanglement. And you measure both states. And I'm going to perform 16 experiments. So I will measure the state. And what you expect, if the first qubit has 0, the second has to be 1. If the first is 1, the second has to be 0. They cannot have both the same states. Those are forbidden states or quantum errors, which in real equipment, we will have this as of now. So you will observe that if I move this to the real computer, to the quantum computer, the state will be sometimes not as we expect. So take a look. If I run 16 experiments on this quantum simulator, we will have, if I have state 0, the other state, so the other qubit has to be 1. And those are errors. So this is the state 0, 1, and 1, 0. So not like we expect. Yes, so this is something like forbidden states. And you see on simulator, they are always 0. So we do not have errors because this is pure math. And take a look. Here, I have state 1 on qubit, on first qubit. So the second qubit must be 0 without communication. Because remember that this is instantaneous operation. There is no information flow between them. This is how entanglement works. And let me show you something about the computer. So now it's the most exciting part because you have free access to IBM computer, and we will go there. And IBM gives you the opportunity to use quantum computers with 1, 5, or 15 qubits, so you can decide which one you want to go. It's enough to go to this address, quantumcomputing.ibm.com. This is where we go just in a second. And I will apply the same code, and I will run the code on this computer. And the same will be, but with different topology, will be possible soon in Azure, as I mentioned. This is how quantum computer looks like. It's not like your laptop. And the reason why it looks that way, because as of now, the computer has to be cooled down to almost ground temperature. Ground means 0 kelvins, almost 0 kelvins. And the reason for this is how the quantum state is revealed. And just to show it what I mean, let me paint this here for you. So I don't know how much you know from chemistry, but it looks like that. Where am I here? I would like to do it that way. So we have so-called ground state, which is the absolute 0. This is 0 Kelvin. And this is the moment when almost everything is not moving in the vacuum, in the quantum vacuum. It's, it's not possible because there is a strange effect which says that you cannot have everything which stands still. Something has to move a bit, and this is a physical constant which is called h bar, which is called uncertainty. Which means that if you try to measure a particle, you cannot measure its position. So we can you can say that we cannot measure its position like x, and momentum, so how fast it moves in the same time. So this measurement has some uncertainty, and this uncertainty is always greater than or equal to this very small constant, which is called h bar. But remember, without this constant, we will not be around. This constant, this h bar, which is like 10 to the minus 35 or so, it is so tiny. But remember in which scales we are now operating. So if you measure a position with very high accuracy, so we can say that I'm trying to measure a position of the particle, then if I try to measure this position with extreme accuracy, I will do a very big error of its momentum. So I will totally miss its speed. Momentum also is about energy, because those two things has to be always greater than this h bar. So you cannot have absolute 0, and you cannot have particles standing still. On a very basic level, they will oscillate, which means they will constantly have a different energy levels, which mean on a quantum level, we will have a very clear separation between state 0 and 1. So you are able to measure it. You know, it's like a tiny milli or microvolts, but you can measure it. If we are moving towards our scales of our temperatures, like 21 degrees or so, those lines are almost undistinguishable. So in our scales of temperature, those are like this. You cannot distinguish them. So you have to cool down this computer to almost ground temperature to be able to perform quantum calculations. This is because, and this is why this computer, sorry, this is why the computer looks like I was showing it to you. So it's strange because you see it has a lot of, you know, it has a lot of pipes. It looks like this because it has to be cooled down that way. So you see, probably this is the moment when you create the entanglements or so, and this is how you measure the operations. So you know, it's not a very cheap thing right now. You cannot go to a MediaMarkt or Saturn or whatever computer shop and tell them, give me a computer, quantum computer. So maybe in 20 years, 10, 20 years, this technology will be a little bit different. As of now, it looks like this. So you can imagine it's not possible to run every possible you know, algorithm on this computer. But I would like to, as of now, I would like to go to the IBM thing. So let me open it. Okay, let me open my browser. So let me do this for you. Okay, IBM Quantum Computing. Where is my browser? I'm trying to, yes, now I see it. So this is the web page where you go. I have 10 minutes, it should be enough. So once you are in this web page, what you have to do, you have to log into your account. You can create it for free. You will never be asked for any credit cards. Everything is fine. Don't worry about it. So no worries, everything will be fine. Take a look. On the right side, you have those computers, and you see they are pretty loaded. So you have like 18 jobs, 14 jobs, 66 jobs. But there are computers that, like in Melbourne, this big one, this one, it has 15 qubits, and there are a lot of people trying to play on it. So we have to choose a computer in which you don't have that much people operating on it. So I created today, you know, I created today some experiments to show you what we can do. But as we have 5 minutes or 10 minutes, I will do the experiment on one of those computers that are placed in different parts of the world. And of course, there is also an online simulator that has 32 qubits. So you can play also on an official simulator. But first of all, what you have, so this is you can choose one of those computers to perform calculations. You have informations about the jobs you already started. So I have some experiments to show you, but we have only 12 jobs in Athens, 8 and 18 in Santiago in South America. So let's try to do at least the entanglements. So here what you have, those are the systems, and you see how many jobs are there. And also I have everything, all information from jobs I started, so the code I started already. And I also do quantum calculations. So you have choice. You have run your code in Qiskit, so you can put your code here and try to do the coding, and the code will be translated to the quantum circuit, and then you run the quantum circuit where? This is on Valencia. No, I'd like to go to Athens. You see, I'm switching to different to Athens. I have 5 qubits there, and I will perform 8,000 experiments. And you have 5 jobs per day, I think, for free. You can use. So let me build this quantum circuit. I will do it. I would like to do only 2 qubits. And I will perform this quantum entanglement for you because this is the very basic experiment you do. So I'm doing Hadamard gate. This is superposition. I'm doing T-not gate, which means I'm going to perform a quantum entanglement. And after this, I'm going to measure the states of the first bit and the second bit, qubit. And take a look. The probability is that they should be 1 and 1, or they could be 1 or 0. As we have 2, we should have states like the forbidden state is 0, 1, and 1, 0, and we see if the computer works. This is the code that was generated. The code is pretty, the code is pretty the same. I show this in Jupyter Notebook. So now let's send this code to the quantum computer. So we'll see where we are just in a moment. So let me go to the jobs. And probably you see our job is now right in a queue. But I have also 5 minutes left. So let me go back, and once it's going to, to be run, I will show you one experiment. And please think about it that way, that this is an algorithm which will always be faster than classical computation. This experiment and this algorithm is called Bernstein-Vazirani. And the idea is that you have something which is unknown string or stream of data. And you would like to reveal the stream of data in one operation. So it is like cracking. It's like that you would like to reveal what is hidden in some, it could be your credit card number or whatever you would like to have. So now I'm showing you the bad part of the quantum computing. In a classical computation, you would have to, on each bit, you would have to perform operation like this. So modulo 2. And after, so if you have 8 bits, you would have to do it that way, that for each bit of your function, which is unknown, so this is what you would like to reveal, you would have to perform modulo 2. So you will have to, you will have like a sliding window of bits. So the bigger the string with data is, the more bits you would have to have, and the more classical operation you would have to do. So for 8 bits, you would have to perform all of, for thousands of bits, you would have to perform thousands of operations. In quantum computer, you will do it in one operation. And this is how you need to, this is the algorithm which was described by Bernstein and Vazirani. And they told that you have to perform, you have to build for 8 bits, you would have to have 9 qubits and 8 registers. So all of the qubits have to be, you have to make them in superposition. So the 8 qubits, the remaining one, the 9 qubits, has to be first put on X gate. X gate is like a knot. It's classical knot. So you just flip the state, the initial state, and you put it on Hadamard gate. And this is where the unknown function will be applied. So this is like an input to your function, to your quantum system. So it looks like this. Then we have so-called barrier, and the barrier says that whatever happened previously should be done in one step. So it's like sequential programming in quantum world. So I put a barrier. Then there is when the function is applied. So this is unknown, but this is like an input. So this is unknown for the quantum system, but it's known for me. So I am applying such function. So this is the stream of data I would like to reveal, and I am putting this on this last qubit, this one. So it's like an input to our system. And how it works, we have to count from right to left. So if there is a 1 on the very right position, we put it onto the first qubit. Then there is a 1 on this position, so it goes to the qubit number 1, etc. So qubit number 4 is this, qubit number 7 is this. So this is how the function is applied to the remaining part of the qubits. But the function can be changed over time. Then we put another barrier. Then we put another Hadamard gate on our 8 qubits, and then we measure. And this is how the state looks like after all. So those are qubits, qubit 0 up to qubit 7. Those are qubits which are participating in the algorithm. Qubit number 8, this is where the unknown function is applied. This is the function. It can be changed over time. So we apply the function, then we perform Hadamard gate one more time, and we measure. Once we do this, once this is done, we can reveal the operation, the unknown function, in one shot. So this will be only one step and one possible measurement. And take a look. This is what we'd like to find. This is what, sorry, we'd like to find. And this is what the quantum system found. Exactly the same state in one operation. So in classical computer, you would have to spend 8 operations. Now we did it in one. And I also, so let me go back to our jobs. And today I was able to run this algorithm for you, but I created it in 4 bits. So because I have only the computer, you know, the biggest one that was quite free, it was the 5 qubit computer. And you see, I applied to it this operation. So I had my circuits, and this is how the algorithm was applied by me prior to our meeting. So I did it on 4 qubits. That was the unknown function. That was the unknown function. This is unknown because you put it from outside. But I decided it will be 0101. Then I measured it, and this is the state. And take a look. That was actually what was found. So it is 0101, and the 0 from here is from this qubit, which is not important for us because this is where the system is connected to outside world. So we don't care about this very right qubit. We just care about those two. And this is how it was revealed during, you know, composing. But then that was really run on the quantum computer. So it was run here. I hope that was that one. And take a look. The case is that 72.5% the probability was that we are right, but we still have some quantum errors as of now. So this is where because the quantum computer is not yet a very perfect thing, and you can imagine that there are still things you have to work on. So if you, for example, have a computer that has 16 qubits, so you can only operate on, let's say, 12 of them, because 4 qubits are used for operation which is called quantum error correction. Like in your MP3 player, you also have some kind of correction in it, implemented in it, to make sure that the sound is clear. Same is here. So physicists know how they know how to do the quantum correction. So maybe in a future there will not be such big quantum error, because as of now you see in this algorithm 72%. So it would collapse to this part, but there is still some errors. And if I go to some other jobs I created last week in the other SQLSat, so I created for them a very simple algorithm, and I try to.
Please the time.
Yes, I just need 1 minute. So you see, I showed them the quantum entanglement, and it was almost perfect. I mean, we have 7% of errors, and everything was fine. Everything else was fine. So let me just do a quickly check. Maybe you see, our job is going to start in 30 minutes. So there is a big queue right now. So we would have to wait for half an hour to make sure that our job will be run. But still, you can do this. Guys and girls, thank you very much that you joined me in this exciting talk. This is the future, and we will be participating in this future, because quantum calculations, they are now, people are trying to use them for the most complex problems you can imagine, like that you have, for example, 800 salespeople, how to plan route routes for them. They have to go with some certain constraint to different places. So this is where quantum computer can help now. It is not yet useful for us, but it will be. Like we could have said that back in year 1999 or early 2000, we were not able to run machine learning, but now we can. The same story will be for quantum computing. So stay tuned and try to play with this quantum computer now. Thank you very much. I will send you the deck and I will send you the code so you can start do quantum computing experiments now. Thank you very much. Have a great Saturday and see you in person maybe next year in Plovdiv.
Okay, here is no question. Thank you.
Thank you.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances to yoga classes to pizza making and fitness challenges to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play staff poker games. These ran alongside our incredible celebrity tournaments, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at PokerStarsCareers.com.
And the last lecture in this track is Machine Learning, Best Practices and Vulnerabilities, and the lecturer is Sebastiano Galazzo.
Hello. So here we are. Can you hear me? Can you
Yes.
see everything? Perfectly.
Yes.
Tell me when we can start.
Yes.
May I?
You can start, please.
Okay. So, first of all, let's thank, of course, our sponsor, even that I think you saw this slide a lot of times because we are at the end of the day. So, thanks again for being here. You are for sure a hero to last until this time. So, who I am? My name, for people who don't know me, is Sebastiano Galazzo. Came from Italy. I'm a Microsoft MVP, and I deal with artificial intelligence since 20 years now. And I'm the CTO of an Italian-based company named Systemevo. And of course, we are focused on AI and machine learning. Here you can find my LinkedIn page and my email. So if you want to keep in touch with me, don't hesitate to write. And if I can, I will be happy to share my knowledge or everything else. So about this session. This session is basically split into two parts. The first part is focused on best practices of machine learning, and it's something that I learned along my path during these years. And the second part is focused on vulnerabilities of machine learning. And I know that this is the end of the day, so maybe you could be scared about some math formulas, but don't worry. I will try to make them easier as possible. So let's start with the best practices. Talking about best practices, I wish to start with a bit of story and talking about the perceptor, that is the grandpa of the nowadays machine learning. Because I guess that is really important to understand for people who don't manage very well machine learning or you buy about this word, how it works. So the idea behind the perceptron is that it tries to emulate the human brain. So it was inspired by the biology of our brain. Of course, there is still nothing that can compare it, but it works like the shells and the synapses behaves. So you have to think to our cell like a switch, and to synapses or the connections between the cells like a wire that is able to propagate electricity, and so it makes our brain like a giant processor where each cell is, of course, as I say, a switch that is able to perform the idea of true or false. So combining all this information, we can compute very, very complex tasks. In the early 50, because everything started in the early 50, of course, the math model was really, really simple. And basically, you have to think, when you think a machine learning model, the perception is the smallest thing, the smallest math model, and is basically model that is made by an input that is a vector of values having a value between 0 and 1, where 0, of course, is not turned on and 1 is on, and connected by weights that are going to simulate the passage of electricity. We do that with the algorithm that you can see on your right. So, where each element of the input basically has a meaning. And it's very important. We will understand why in the next slide. It's up to you to assign a meaning to each neuron. To understand better what we are talking about, you have to think, for example, to that game that is named Akinator, that tries to understand, to guess what you're thinking. So he does some questions to you. So, for example, is it alive? Yes or not? Or is it a cartoon character? Yes or not? And so on. A lot of questions. You reply with yes or not. And each question is basically an input that is true or false of this vector. All these values are summed all together, multiplied by a weight. All of that to say what? That basically a machine learning model is a classifier, because the answer is something, is a well-known output that you have decided what it is, and there is no magic. Everything is the product of a sum, multiplications, divisions. So, of course, along the year, everything has been improved, and now we have much more complex algorithms, but basically they works like this same regression. So, for example, if we talk about logistic regression, sample vector machine, at the end, what we do is to solve a system like that, where we have to find some kind of parameters. Again, no magic, nowhere, sum and multiplications. Well, the most complex model that we know are neural networks that has these shapes. Well, we can classify all that algorithms and be aware that this is my own classification, of course, it's my own opinion, in what we call the easy way and the hard way. So when we talk about the easy way, I'm talking about the logistic regression, sample vector machine, and the pro is they are easy and fast to use. The cons is they have low accuracy compared to neural networks. And the other way, of course, is the neural network, and in my opinion, they are much more difficult to deal with, but if you are lucky, of course, and good, sometimes they have a far away better performance. From now on, we will work with neural networks, okay? So, let's start with the first example. And to introduce some techniques, we will take into account this example. So it's a very, very small problem we have a few parameters like the age, the gender, the income, the city, and political party is the category that we have to classify. So basically, with this model, what we want to do is to understand that profile, that people profile will vote what. So Democrat or Republican. Based on this value, the naive method is to assign, as I explained before in my introduction, to select each neuron of the neural network and to assign a meaning. So, for example, the first neuron is true or false if the age relies on between 0 and 17, and the second neuron if the age is between 18 and 24, and so on. For the 10th neuron, if he's male or not, and going on. So you will understand that our parameter, our math model, sorry, has more than 20 parameters, and we are not taking into account so far the data of the city. Let's focus just on age, gender, and income now. So, of course, the method that we used before is not the best one. And the one technique that I used with a very, very good result is, for example, this little improvement where I divide the age by 100 and I use a value that is a fuzzy logic, because we said, that the input of a neural network must be 0 or 1. But in a lot of cases, in much more complex cases, we can use also different kind of input. So that are in ranges between 0 and 1. In this case, for example, if I have an age of 42 and divided by 100, the input of my neural network is 0.42. What it means? It means that if before I used, for example, 10 clusters to manage the concept of age, with this simple trick, I can reduce everything just to one neuron. And most the same thing I can do with the gender, where here I used another technique that it works because I tested in a lot of conditions, but be aware that you can use it always. So in this case, we have just 4 values, for example, male, female, prefer not to say, or other answer, and dividing by 4, I can assign, and it's up to me to select the meaning of each value. That, for example, 0, it means male, 0.25 means female, 0.5 other, and so on. This works, as I said, but be aware that it works when you have enough gap between between values, because in this case we have a gap of 0.25, and based on my experience, is a very good value for the gap. But if the gap is too small, then the math model is not able to understand if we are talking about male or female, for example, of course. Well, something like that, of course, can be applied also with incomes. Anyway, these are the first techniques that we can use, and are very, very simple. But these simple techniques are are already able to reduce a lot the dimension of my math model. But why? Before introducing the next technique, let's try to understand why it's really important that we have a small model. People believe that the bigger is the math model, the better are the performances. This is not always true, because if you think to the behavior of the math model and what it does, it basically tries to solve an equation system, like the one that I showed you in my introduction. And being the result of product, sums, and multiplication, the first problem is that the biggest is the math model, the more resources you need. More resources, it means costs. Costs, it means, times and cost. And when we are talking about cost, despite compared to the previous years, they are now far away lower. Anyway, to manage to deal with hardwares having, for example, GPU or machine learning dedicated are still expensive compared to other kind of hardwares. But the main reason why we need the smallest possible math model is that it's easier that it will work, because adding informations, we will increase the possibility that let's say the signals lost is something wrong, but it is a kind of example to explain to you by what happened. So you need to force all your operations to reduce the dimension of this math model. So people that have experience in machine learning, please forgive me if I use this kind of example, but it is I try to explain for all people. And forgive me also about the description of the next technique, because this is not a math lesson, so I will provide a very high explanation, but it's really important that you understand the method that I used. So let's introduce the standard deviation. The standard deviation, you have to imagine to standard deviation like a value that tells you how much the current value is close to the average. Okay. So let's imagine to standard deviation to something like that. This is the formula of the standard deviation. You can find it easily on the web or in the math book. And now let's try to understand why that could be game-changing used in our machine learning algorithms. Let's figure out, so let's imagine the first example about the age, for example, or also about the in-game data, and about the first technique. So when I used several clusters, for example, the cluster 0 to 17, 18 to 24, and so on, and the same thing also for the salary. And let's imagine that we have to classify if someone will buy an Harley Davidson or not. It's a very expensive motorbike, and the stereotype wants that people in the middle age buys this kind of motorbike, people with a very good salary, And so if you have a classification of your data like the one that we did in the beginning, what could happen? Could happen that if the best range of people that wants to buy this Harley Davidson is between 40 and 60, and I'm 38 with a very good salary, with the perfect area, and with all very good parameters, but the age is a very good, is a very important parameter and value. I, for just a small amount of information, I will fall in the wrong cluster, and it could happen that I will be classified in the wrong way just because I'm 38 and not 14. But being 38 with all other parameters that fit the perfect profile, for a human being, it's good. But maybe that will not happen for several reasons, because of the game of math and multiplications. Could happen that I will not fall in a good classification. But if I use an approach like the standard deviation, I can fix these kind of issues, because basically if I am 38 and the average of the people that buys the product is 40 or 41, I'm so close that and then I will produce an input value that is much more accurate. But let's see how to apply it. First, we need to process all our data and to calculate the average. For example, in this case, we are talking about the age. And then we can compute the standard deviation using this simple formula. This is something that in Python you can perform in 1 or 2 lines of code. But how to use this value? Well, the value that you have to use as input of the neural network is the current value minus the average divided by the value of the standard deviation. Then, just for example, if I have an average age of 40 and a standard deviation of 8, 12, so the final value is minus 1.23. So 2 things, very important. The first one, the value doesn't fall between 0 and 1 or between minus 1 and 1, but is out of range. And you may say, that's a problem. Of course not. This is also a suggestion that I can provide. You can use, in some conditions, even values between minus 5, for example, and 5. So that's not a problem, but it's something that is not common. Of course, if you want, you can normalize, but I don't suggest that. The second thing is that is a value that is not understandable by human being, because the main error that a lot of people does approaching the machine learning is that they try to model the data to be understandable by them, but not by the machine. So to turn on the cluster from 14 to 16, it's easier and understandable compared to understand minus 1.23. And this is not comfortable, but is far away better for from a math point of view. Well, let's introduce so far another technique that is called the binary compression. And here we have to introduce how to manage the data like the city. And here I have to tell you a very, very short story. That when I was working in my former company, there was a team that was working on data like that. And in Italy, we have more than 8,000 cities. Well, they created a neural network with more than 8,000 neurons. Together, joined with values of the age, the income, and other information. They spent six months trying to make it working until someone was very upset about that fasting of time, and then I was invited to join the team. And the first thing I did, it was to use that technique. So how it works? We say that we have to reduce our math model, whatever it takes. So we can see that 2 elevated 13 has this value, 8,192, is a bit more than the number of cities, of Italian cities. And then it means that I can create more than 8,000 unique masks using this binary sequence. So Milan is a sequence of all of 13 zeros. Turin has this mask, and so on. It means that I can manage that value with just 13 neurons compared to 8,000 neurons. Of course, you can understand easily the advantage of using this technique. First, because we were able to reduce the amount of complexity, and then, of course, reducing the cost and the accuracy of the math model. But that was not enough. This is something that I showcased to show the technique, because anyway, there was a main mistake in their assumption, because they worked with the name of the city. But to go straight to the point, for a math model, what it means Milan, what it means Rome, what it means New York, it means nothing, exactly nothing, because it's just a sequence of charts. So what I did, it was to download the database of all Italian cities where and there were numbers like the dimensions in kilometer per square, the number of the population, and the density, and all this kind of data. And then I discarded the name of the city, and I used this data and transformed and managed all that number to understand, for example, how big was the city, because this was the real useful information. So if I buy an Harley Davidson or not, or if I will vote for this political party or not, maybe the real reason if I live in a big city or in a rural, in a country city, or in a very small village. So using all these techniques, we were able to reduce the dimension of our parameter from 8,000 to 5. What it means? It means that 5 parameters can be also managed without the use of the neural network, but even with a sequence of if then else. Of course, is a big joke. I don't want to say don't use the machine learning. The point is that nowadays, if you don't use the machine learning in your project, it means that your project is not cool. And this is totally wrong. There is no magic. The 95% of this job is on data. And there is nothing smart from the machine here. If there is someone that is smart, it's you, that you have to understand the data, manipulate them in order to make them understandable by the machine, not for the humans. This is the key point and the main mistake that a lot of even expert people does. Because machine learning is a black box. We don't know exactly what happened inside. I mean, we can't fix what happened inside, and so is human to make to manage the data to be at least understandable in the input. But as we saw, it was far way better for the machine to use the standard deviation and then a value that is not understandable, like -1.23, compared to a meaning like 40. So this is the end of the first part. I hope that I was able to send the right message, and then we can switch to the second part or the vulnerabilities. So to introduce this topic, let's imagine that you run an e-commerce website like Amazon or eBay, and your need is to prevent people from selling prohibited items, but much more to upload unwanted content. For example, that could be adult content, why not? So to do that, maybe 15 years ago, what you had to do is to hire hundreds of people in order to check, to review all the content. But if you are talking about machine learning, AI, how magic it is, it's obvious that nowadays in 2020 we have to use the deep learning. So the deep learning used in image classification, it's amazing. It's amazing. You can use this kind of technique, and I would say that it can do nowadays a very amazing job. I will explain after how the convolutional process it works, but now let's recap very, very quickly how the training process it works. So let's say that we have the image of a coin in this case, and I have to train my neural network model. How it works that I provide an input, an image, then of course at the beginning it will not be able to classify properly, and the error will be used in backpropagation to fix the weights. Let you remember the perceptron, the weights between the neurons. They are adjusted. After some epochs, of course, my model will work in a perfect way with a very high accuracy of the 98%. Now I'm very, very happy, and then I can upload my model in production. Well, we already said that convolutional neural networks works very, very well, and even so well that nowadays are really able to outperform humans in this kind of task. We are talking about image classification. Let you remember that. So, if they are able to outperform the humans, I expect that if I provide in input an image like the coins below with a very small artifact for a human, so if you are so good, even better than me, and as a human being, I am able to still understand that it's still a coin, my expectation is that even the math model has this kind of capabilities. Of course, if I'm doing this speech, it means that it was discovered that isn't always true. In fact, it's been discovered that altering some pixels, we can hack the behavior of the neural network. So we can completely fool the neural network. I guess that nowadays a lot of you, at least, were able to hear this kind of technique. But let's try to understand why this. So we said that machine learning is basically a classifier and tries finding a dividing line between between the things that is trying to tell about. Well, we have to think to the dots like an entire image, and in this we have to find the smallest amount of altered data that makes that an image moves from one border to another. So, as we are talking image, then millions of pixels and then data, it means that we have thousands of possibilities. There is not just one. And that's important, and please keep in mind this information to understand better in the forward slide. So basically, what we have to do is to add some noises to our image in order to fool the neural network. And this is one of the main approaches. So to understand better how is possible all of that, let's try to understand better the behavior, how the convolutional process it works. So when we have to classify an image, what we do is divide our image in a small square and apply some filters, the same kind of filters that you can find in Photoshop, and named age detection. So I'm talking about the filters that makes your image green, gray, with all ages highlighted. So, but in Photoshop, you apply just one kind of filters. Here, you apply thousands of these filters. Each one is specialized to find some information. For example, some filters are specialized for vertical lines, other filters for horizontal lines, and others to find all other kinds of details. So we perform several steps, several layers of this process, and at stage one, we work on the full image, we apply filters, and then we reduce by half our data, and then we repeat this process. So we apply again these filters, and then we reduce by half, and so on, until we produce the input for the final neural network. It is as the same structure of the neural network that we saw before. So this is how it works. Then this is a filter, an image, a simple image, and then I applied a filter using Photoshop of this squirrel, and then let's imagine to add some noises. We are still able to understand that this is still a squirrel. You can see here the view boxes. If we go forward to the next layer, to the next step, you see that we have this result. Going forward again and again. So there's no need to continue. It's easy to understand based on information that I provided before that are altering a small amount of the picture because of the convolutional process. This error is duplicated to the end, and then the whole input of the neural network is altered. Sorry. So don't believe that it is very complex to do something like that. We are talking about a few lines of code in Python, and it is a really simple while loop or for loop. As you can see, for each image you apply your noise, random noise of course, until you find the correct target. So how we can protect ourselves against this attack? You can do something. The most known technique is to train our model or a second neural network with altered images in order to say just if it is a fake image or real image. It can work, but as I will show you after, it's most useless. The real truth is that there is nothing to do, exactly nothing to do, because this is just because of the math behind the machine learning. Well, now is the time of the demo, and I will show you how easy it could be to hack a neural network. First, let me explain that. I will show you this technique using basically Photoshop or GIMP. If we try to hack the neural network using code, of course, I can find the way to hack the neural network altering the image using a very small amount of information in order to make it to be invisible by humans. It means that if I see the image of a cat, of a portrait, and some pixels has been altered as human being, I see nothing. But what I will show you is something that has been altered using the Photoshop or GIMP or Paint, and then the perturbation and the modify is bigger, but that doesn't change the main problem. I selected this kind of demo, and not to show you the code, to show you how easy it could be. Even for people that do not understand something about IT, about machine learning. Even my 7-year-old son could hack a neural network using some tools, because it was easy to hack something using Python code, but would have been something for nerds or for technical, for developers. But the real truth is that everybody can do it, and to provide some damage. Well, the demo. Of course, okay. No, it happened. Okay, here. So I used the Microsoft Custom Vision.ai. Is an online service provided, of course, by Microsoft. Is really powerful, and you can upload your custom images, create your machine learning model. You can download it and to use in your applications. It can be downloaded for iOS, Android, so for mobile devices, or also for desktop, for biggest hardware. And I used this service not just because I'm a Microsoft MVP, but because nowadays, at time of speaking, in my opinion, having tested most all services and also provided by the results that you can find in the web, Microsoft has the most powerful service that you can find in the market so far. So I'm using this service not to show that Microsoft has a problem, but how easy it could be to fool the most powerful service. So again, I'm not talking, I'm not saying don't use Microsoft. The opposite, this is the best service that you can find, but the message is that nobody is excluded by this kind of problem. Well, what I did is to create 3 clusters. So bottle, people, and squirrel. Of course, the model has been trained for this demo. And let's do some tests and use our squirrel. And it works. It's a squirrel at 100%. Let's use me. I'm a people at 100%, and using another picture, let's say that the model is working perfectly. So now let's use something like Paint or Photoshop and introduce a change. So an obliquous line like that. Just that modify, as you can see, is an obliquous line. paint here has been able to reduce the accuracy of the math model. It's the same image, just with an ambiguous line. So I'm still a person with a probability of 62%, but I'm also bottle almost at 40%. Well, let's try something different, adding this kind of noises. And using vertical and horizontal lines, I'm a bottle at 95%. Well, now, what you can say is that, okay, but you altered the image too much, because it's normal that if you modify the image so much, the math model is fooled. Okay, perfectly. Then what I do is to upload this image where all the faces is blocked with a big box, a big white box. So guys, I'm back a people at 99%, and the model, the face is completely hidden. Well, let's try something different. So, changing the saturation, so the amount of colors. In this case, I reduced the saturation of the skin and changed the color. And is the same modified that I did at the beginning, but here, again, compared to the same modified, just changing colors, you can see a different result, because I'm a people at 91% with the same picture, but different colors. The first one here is 62. So, just changing colors again, I outlined that. Well, now let's try again something different, and I tried to modify in the key point areas of the body, but I was not able to fool the neural network, because it's still able to classify that they are people at 99%, so with a very high accuracy. And then the approach is to try something different. Okay, altering the background, so not the main content, I found that this is the right direction. So there are people at 75% and bottle at 25%. Well, again, let's try to change colors. So it's exactly the same image with saturation changed, and we are back to high values. Well, now, of course, I am showing you 2 running people. But what if it was an adult content image? Because you can say, okay, but you are altering the background. If I have an e-commerce, nobody care if I upload the image of a picture of a laptop or of a smartphone, something to sell with altered background. Okay, but what if I'm someone that I want to create problems and I upload adult content? Nobody cares about the altered background, because the main topic of the image is still visible and understandable. So if I want to damage you, that kind of modifier is enough, but much more. If we are talking about self-driving cars, it means that if there are some noises in the background, the car is not able to understand something really important that you can crash. So you don't need the perfection of the pixel attack, in the meaning that you have to find the smallest amount of information, what pixel can change something, because nobody here, everybody, writing a no code, 0 line of code using Paint can hack your neural network. Anyway, finally, what happened if I try something a bit different? Here we go. So, changing just a little bit the noises in the background, I was able to totally classify in the wrong way my image. Again, don't focus on these samples. Imagine the situation of a very big customer, like that would be like a bank, or anyway, a big customer, or security scenarios, or driving cars. You understand that I'm not saying don't use machine learning again, don't use this kind of services, and I showcase that it's impossible to avoid this kind of technique, because you can train your neural network with altered images, but I showed you that if you change a little bit the saturation of the same image, I am still able to change the result of the neural network. So I can find millions of possibilities to fool your neural network just using Paint. The final message is not don't use these tools, but that you must be aware of these kind of issues and based on the project you are working on. So, from my side, it's everything. I hope that you enjoyed this session. If you have any questions, here we are. And anyway, you can write to me, you can keep in touch, and I will be happy to answer to all your questions. Thanks, everybody.
There aren't any questions. Thank you very much.
Thank you very much, Sebastiano.
Thank you to you for the invitation. I hope to meet you in person the next year. So
Next year, maybe.
Yeah, we hope. Bye-bye.
At PokerStars, we believe in uniting and celebrating those who share our unique mindset and putting our community of employees and customers first. This approach has kept our company culture strong. It doesn't matter if we're at home or in the office. Wherever we're based, PokerStars will always be where the best play. Behind the scenes, we've stayed closely connected through our company Facebook group, where our people have been sharing what they get up to at home. It's given us an opportunity to socialise with international colleagues in a completely new way and give a warm PokerStars welcome to our 467 new hires within the first half of the year. And as experts in entertainment, we've naturally been getting creative. From TikTok dances, to yoga classes, to pizza making and fitness challenges, to musicians, sunrises and lots of pets. Beyond sharing photos and videos, we've come up with tons of ways to entertain each other. Our company-wide bingo and quiz nights have been a hit, and we've tried and tested our own products with a 60% rise in joining free-to-play stacked poker games. These ran alongside our incredible celebrity tournament, which raised more than $1 million for charities around the world. Oh, did we mention our own celebrity? Back in May, we held our biggest and best scoop event yet, when a PokerStars ambassador won a new world record for poker on Twitch, peaking at almost 60,000 concurrent viewers. As we begin an exciting new chapter as part of Flutter, we've never been more proud of the engagement and passion of our people. Thank you all for keeping our community entertained. Want in? We're hiring. Apply at pokerstarscareers.com.
file or administrate scripts. Both loads into a database or create an external table. One of the notebooks we can look at whether the frame or smart table, and these are the smart tables. By the way, amazing thing, you can get this simple world with the smart world, very easy way, so you can do things from the tables in smart simple world or vice versa. So this is amazing as a product. Still a lot of bugs, but amazing as a product. Anyway, give it a try. Here's some demos on this online. And in my part, this is all I have. I know we're running out of time. For this session and for all of the other sessions, I know that you have some evaluations in SQLSaturday website. Feel free to evaluate. Evaluations are important for the speakers to know what they did well and what they did wrong. And this does not give us any extra food at this point, but anyway, still very useful to get from your feedback. And if you have any questions, I'll leave this up for later if you want it using LinkedIn or Facebook or something like that. And just want to thank you all for being here at this point. So, Mikhail, how are things? How do you have a great wall behind?
Absolutely. So if you can close Andre, but hope to escape next year, and I have some interesting announcements, interesting also for you. So just I need to share my screen to do that. And this will be the code. So it is time actually for last minutes. First, thanks to everyone who joined this event. Special thanks to our partners, because without partners, we are not able to do this event. Really, it was very important that some of local and international companies support this event. And special thanks to our team, our volunteers, and these people actually did everything around the organization. So really, thank you for this. I appreciate very high your effort, and it will be one awesome event. Some statistics. Actually, our numbers are going higher. We have till this moment 15 people Saturdays in Bulgaria. This is 15 Plovdiv, and we had 195 registered Saturday website today, and more than 200 already by Gold webinar, and even more additionally by social networks. But recordings will be available, so many people additionally will able to join good content after closing this conference. And don't forget, we are starting work on next Saturday morning. For now, target date is June 21st, depending on situation, because we really would like to make this event in person. So consider the dates that probably in June, if everything is fine, we will have an awesome SQLSaturday in Plovdiv after 6-7 months. So thanks again, and hope to see you again next year.